Bignar sir.
Yes, sir.
Yeah, we can start our session, sir.
Okay. Sir, actually, I have connected here by using two email ID.
Okay.
Uh, and
So, are you
and
presenting using this or using another?
no, another one, sir. I am sharing the screen from that ID.
Yeah, you check now and you can able to present, sir. And before that, we will have a short intro about you, and
Okay,
then we can get into the session.
okay, sir. Fine.
Okay.
Thank you.
Amuda, ma'am.
Yes, sir.
Yes, please.
Okay, thank you, sir. On behalf of our management and department faculties, I welcome our chief guest, Dr. Bighnaraj Naik, sir, who is working as an assistant professor in the Department of Computer Application, V. Surendra Sai University of Technology, Odisha. He has published more than 130 research articles in various reputed peer-reviewed international journals, conferences, and book chapters. He has edited 15 books from various international publishers such as Elsevier, Springer, and IGA Global. At present, he has more than 30 years of teaching experience in the field of computer science and information technology. He is a senior member of IEEE and his area of interest include artificial intelligence, meta-heuristic optimization, data science, data mining, machine learning, deep learning, computational intelligence, and its applications in science and engineering. He has served as guest editor of various journal special issues in information fusion, neural computing and application Springer, evolutionary intelligence Springer, International Journal of Computational Intelligence Studies, and International Journal of Swarm Intelligence, etc. He has completed one funded research project in the capacity of principal investigator, which is funded by Science and Engineering Research Board, Department of Science and Technology, Government of India. We welcome you, sir. I'm sure that today's session is going to create a great impact on us. Once again, I welcome you all to this auspicious session. Thank you.
Thank you, madam.
Thank you, sir.
Shall I share my slides?
Yes, our slide is visible, so please maximize it so it will fit the screen.
Okay, sir.
And to be from my side about Dr. Bighnaraj Naik, he's a close friend of mine for past 6 years. We have a strong research connectivity, and we have altogether around 20 to 30 publications. And he has edited around 20 books, which is a remarkable and achievable thing. And also, he's one of the editor member for hosting the conference CAPR, which is a renowned conference. Altogether, it will be every year. It will be run by Springer series, and it is a very prominent conference associated with NIT, IIT, and IISc. So he is one of the key member in that area, and whenever his name was in the Springer series, the people will once approve the based on his quality and his reputation, and he is one of the strongest researcher in Odisha. So this is I want to convey from my side. And Mike sir, please go ahead, sir. Welcome you once again, sir.
Okay, sir. Sir, thank you. Thank you very much. Uh, Here, good morning to everyone. A very good morning. And my topic here, I'll be presenting on ensemble learning. Sir, am I audible?
Yes, we can hear you.
Yes. Ensemble learning is a part of machine learning. I don't know about the complete audience, but I'll assume that most of the audience will be acquainted with machine learning basics, like various model, decision tree, linear regression, how we can build, how we can train a model, what are the performance evaluation metrics available, how we can evaluate variance and bias of a model. These are the assumptions that I will take, that uh, I have to, because ensemble learning is the next level of I can say machine learning. So all these things requires to understand ensemble learning. And here I'll be starting with the disclaimer. Here my idea, discussion, remarks that I will make in this presentation are purely personal, and my organization has nothing to do with it. Some portion of the data, figures, text are collected from internet sources and produced, and I don't claim the ownership on this produced document. Prerequisites to understand this, as I said, uh, we need to have the concept of machine learning fundamentals, like classification model. Under that, various model are coming: decision tree, naive Bayes, linear regression. I hope Bimal sir, yesterday or day before yesterday, there was some session on machine learning.
Yeah. Yesterday, Urvasi ma'am was delivering the session, and she has been focusing on basics of data science, prescriptive, descriptive analytics, also with the clustering.
Okay, so let me know. Is there any discussion on decision tree or any model, how we can build, how we can train?
Yeah, you can go ahead with the decision tree modeling and everything. Yes, please.
But sir, here here I have made assumption that audience know this. That's why I have not kept the concept of decision tree. Rather, I will be starting on direct from Ansible learning. Is
Yes,
that
you can
okay?
directly get into ensemble and you can give ideas about that.
Okay.
Okay.
And here, machine learning fundamentals include these various models, decision tree construction. I'll be assuming that you know this. Model training and testing, performance evaluation, various metrics, bias and variance associated with machine learning models. And also, I will assume that you have some idea on Python environment, NumPy, Panda, Epsilon, and various other things. Uh, Ensemble learning methods. Basically, here we use not a single model. We'll use a combination of models to improve accuracy. Uh, from the data, we are going to train k number of model, and from the k number of model, we are going to use their prediction to get the final output. Ensemble meaning is combining a set of homogeneous or heterogeneous classifier. Homogeneous means the set of model that works, or they have the same skill to do classification. Heterogeneous means they various model they works differently. For example, decision tree have a different logic to do classification when we compare with an naive-Bayes model. Decision tree is based on entropy, and naive-Bayes model is basically which is based on the probability theory. So I assume that all these things and we have popular ensemble models like bagging, stacking, boosting. These are the various approach. I will be discussing on these three approach in brief, and at the end I will be showing how we can improve the performance of a machine learning model by using this concept like bagging, boosting, and stacking. When we must use ensemble learning, when not to use ensemble learning. We are going to discuss this. To the end of this slide, I have another demonstration to show you by using Jupyter Notebook how we can implement these models, bagging, boosting, and stacking, and how we can improve our performance by using these approaches. Baking basically, which is based on the averaging on the prediction over a collection of classifiers. Here we used to choose a homogeneous classifier. That means the model having similar nature of works, or the model they have a similar skill to work on the data. Basically, we used to take the example of random forest, whose job is to choose k number of or n number of decision tree to to create a random forest, and by using n number of model, the final prediction took place. Boosting. So here I am trying to give you the overall idea. Later I will be discussing in brief. Boosting is another approach of ensemble learning where the weighted vote will be collected with a collection of classifier. Each classifier will be focusing on the portion of the uh, 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 samples to classify, and any misclassification done by one model will be focused by another model. Means another model will learn from the mistake which is done by the previous model, and gradually we are going to add model one by one to get boosting model. I'll be discussing again in detail later after some time. Stacking is another approach which takes heterogeneous weak classifier that learn parallelly and combine them by trying a meta learner. So here we will be having two phase of two level of uh, learning. Uh, the model will be learned separately initially. Then the prediction of each model will be combined to get a meta learner. So again, I will be discussing on this concept in detail after some time. Next is when to use ensemble learning. Usually when we are working on any machine learning project or data science project, we can see that in case of complex data set, we may have poor accuracy. In that case, we may use ensemble learning to improve the performance of our machine learning models. For example, suppose we have a different complex data set, and in which we have used to decision tree model, base model, which is giving you the accuracy of 70% or 65% like that. But you are not satisfied with that performance, and you want to improve the performance up to some certain level, maybe 80%, 90% or more. In that case, you can take the help of ensemble learning. And also ensemble learning results a more stable model, more stable in the sense in the point of view of variance. Model variance means how the model behaves when the data set changes. Means when we change the data set for the training, how the model act or how the model behave to that new data set, that defines the variance. We want a model with low variance. Means that the model must be stable. And another one is sometimes a single model may not have the capability of producing right prediction for a particular data set. In that case, we may have a chance of high variance and bias. By combining the multiple model, we can avoid that situation, or we can get a improved accuracy. But here, getting a model with low variance and low bias is a contradictory requirement. We cannot have a model with low variance and low bias. We have to have a trade-off between that variance and bias. But here, ensemble learning technique will help you to get rid of this situation. Suppose you are looking for a model with low variance, or you are looking for a model with low bias. Based on that, you are going to select a model means select a assembly learning technique, either bagging, boosting, stacking, or other version are also available. But this slide will be this presentation will be focusing on these three techniques. Bimal sir.
Yes, sir.
See, anyone can interrupt me at any point of time, sir. No issue.
Sure,
And
sure.
or you may anyone can ask the question by using chat box.
Yeah. Chat box, the participant will use to.
Yes, sir. This my talk should not be monotonous, and it should not be one way. That's why I'm seeking participant. If they have any question query, you can post it, or you can interrupt me, or you can ask the person.
Definitely, sir. Definitely.
And here the basic content will be on ensemble learning basics and the type of ensemble learning approaches like bagging, boosting, and stacking. Uh, this is this is bagging. Bagging is the approach where we are going to take the help of multiple model. If a single model don't works, like suppose we have created a decision tree for a particular data science problem or a machine learning problem we have created, and we have observed that the accuracy is not up to that mark. In that case, what we can do, we can take the help of multiple model. We can create multiple model, and based on the performance of the multiple model, we can decide the final classification model. So here, this is the analogy, like when we take the help of multiple doctor for a particular disease. Suppose somebody is suffering in an unknown disease, and he or she want to know that particular disease, then we can take the help of multiple doctor if you are not satisfied with a single doctor. So this is what the bagging is in terms of machine learning. It is also known as bootstrap aggregation. Bootstrap is a approach. I hope many of you may know this. A bootstrap is a concept where we are going to choose the sampling or choose the sample from the original dataset. From the original data, we are going to create a n number of samples, and for each sample, we are going to create one model. It may be a decision tree. Like that, we can create n number of decision tree, and each time a decision tree will be learned separately from the data that we have created by using bootstrap sampling. Suppose we have created a classifier denoted as mi from the dataset. Mi from the dataset di. Similarly, we can create k number of classifiers by creating k number of per data sample by using bootstrap sampling, and and by creating a model for each data samples, like which we can create a k number of model, and each of the model will give a classification output or the classification. And based on the collection of the classification from multiple model, we are going to decide and the class level of the unknown samples. Here, here while collecting the prediction from each and every models, various here in this case we are going to use majority voting to decide the final class level. Suppose we have we have k number of model that we have created, m1, m2, mk, and each of the model is a decision tree, and that are created from the data sample d1, d2, dt, dk. How this data samples come from, where that data sample came from, the original data set d. And while creating d1, d2, dk, we are going to use bootstrap a sampling approach, and from each of the data sample we are going to create a model like this. For a data samples DEI, we are going to create a model MI. And during testing, suppose there is an unknown sample X, which class level we want to predict. Then we are going to give that unknown sample input to M1, M2, and also MK. And each of the model will return a class level, like it is 1. Model 1 is saying the class level 1. Model 2 is saying the class level 2. And like that, model 1, 1, 1, 2, like that. So we are going to get a k number of prediction. Then after getting this k number of prediction, we are going to use a voting concept. So here majority voting will decide the final class level of this unknown samples. So while using majority voting, here we have two options. Either you can use hard voting or soft voting. Hard voting says that only it will count the majority votes. Like this here, suppose we have 5 number of models. So majority is here out of 5. We have 3 models which are saying class 1. So the class level of this unknown sample will be class 1. This is how the hard voting works. In case of soft voting, what will happen? Each of the model will gives the class level with respect to percentage. Suppose it is a 2-class problem. It is a binary class problem, and those 2 classes, class 1 and class 2. So each of the model will tell the prediction in terms of probability, like that. Suppose here it will give you like 0.4 and 0.6 kind of thing. So here each of the model gives you the output in the form of probability value, and not in the form of class 1, class 2 in case of soft voting. And here this says that the class 1 probability is 0.4 and class 2 probability is 0.6, and each model will give you that kind of output in terms of probability. Then we are going to calculate the average probability of class 1 and class 2 by using the weight of each model. So in that case, we are going to use the weights associated to a model. So how we are going to decide weights? Weights of each models will be decided based on their performance. When each model trained separately, obviously there will be a accuracy associated with it. Suppose the model 1 is having an accuracy of 60%, so weight became 0.6. Similar to that, model 2 has an accuracy of its individual accuracy of 70%, so weight became 0.7, like that. And this value will be acting as the weight of each model, and finally we are going to multiply this weight to that probability, and we are going to get the average probability of class 1 and class 2, and based on that we are going to decide whether this unknown sample belongs to class 1 or class 2. So this is how we are going to use Bayesian for a classification. Similarly, Bayesian can be used for a prediction also. In that case, we are looking for a continuous value rather than a discrete outcome. So here, Bayesian can be seen as a process like this, where we'll be having a original data set. From the original data set, we are going to create bootstrap samples. Here D1, D2, D3, D4 are the samples which are created from the original data set D by using bootstrapping sampling approach. Then from each sample of the data set D1, D2, D3, D4, we are going to create a model, individual model. Suppose it is M1, M2, M3, M4. So these are the models which are created from the data samples D1, D2, D3, D4. And we are going to have a prediction from each of the model. So each of the model will be having having its own prediction for the unknown samples. Suppose the unknown sample is X, and model 1 uh, uh, will predict the class level of this unknown sample X, maybe class 1, it is class 1, class 2, or class 1. Then the outcome, the final output will be by using the process of voting, majority voting, that may be soft or it may be hard. So this way Bayesian works. Random forest is one of the example of Bayesian approach, where each classifier in the ensemble is a decision tree classifier and is generated by using random selection of attributes at each node to determine the split. So here we need the concept of decision tree. I hope you know this, and how the split is taking place while creating a decision tree. In that case, we use the concept of entropy. We have various attribute selection measure like information gain, Gini index, gain ratio, uh, by which will decide which will be the root node, which will be the root of the left subtree, and that will decide how the tree will grow. And here we'll take the help of decision tree as a base classifier. Random forest use the multiple decision tree, and it will create multiple decision tree from the original data sets. Here, as I've said, here suppose we have a original data set. For the original data set, we are going to create 4 decision tree. In this case, this is decision tree 1, decision tree 2, 3, and 4. Each and for each data samples, when we create decision tree, it will be trained separately for this particular data set. So here model M is the decision tree for the data set D1, and so on. And here we'll take the help of 4 decision tree which creates. Yes.
Nayak sir.
Yes.
Sorry,
yes,
sorry to interrupt. The screen is not visible.
Screen is not visible.
Yes, yes. Once again, I will check and. Yes, yes. Now it is.
Aruna Bajpayee, madam, do you have any question? I think she has raised.
Yes, yes, yes. Yeah, please maximize the screen and it will be visible now. Yes, yes. Thank you, thank you. Please proceed.
Okay. So here, random forest is one implementation of Bayesian. And Bayesian is the approach, and random forest is a model that use Bayesian approach, where we'll create m number of decision tree from the given data set. Each time when we create a model, we are going to use bootstrap approach to get a data samples from the original data set. And for original from for that bootstrap sampling, and that sample that we have obtained, for that we are going to create a decision tree. So here it will be a decision tree 1 for the bootstrap sample D1. Similarly, for the D2, we are going to have a decision tree 2, and so on. So here in this case, there will be 4 decision tree, and based on that 4 decision tree, we are going to have a prediction for unknown samples. And again, we are going to use the voting approach, majority voting, either soft or hard, to decide the final class level of unknown samples. So here, as random forest use the concept of decision tree, and it will create multiple decision tree which will be used for the final prediction. We need to have the concept of decision tree, and we have to know how the decision tree created from the original data set, how we are going to use, how we are going to select the attribute. For that, we will be having a various concept like attribute selection measures. We have entropy based attribute selection measure where we can use information gain, Gini index gain ratio. Here also in the same way, while creating random forest, each of the model will be created separately from the bootstrap sampling, and a decision tree will be created. While creating decision tree, it will choose the attribute by using random selections, uh, uh, and which will determine the split. Split in the sense how the data sample will go from root to the leaves, and how they will be classified. Question is why random forest use a random selection of attributes here, because if we stick on a single decision tree, there may happen that there will be high variance. High variance in the sense one decision tree sometime you are running giving the accuracy of for let's say it is 75%. Next time it may have a 78% of accuracy for another bootstrap samples. So here we can say the model is having higher variance. This is how actually that will be determined by seeing how a model is acting, or how the model is behaving to the different set of training samples. So here, random forest will get rid of that high variance situations by creating multiple decision tree, and each of the decision tree will be created by using random selection of attributes. During classification, each tree votes, and the most popular class is returned by using either sub-voting or hard voting concept. This is the basic steps of random forest. I'll be demonstrating in Jupyter Notebook how we can create a base model decision tree, and we'll evaluate the performance of a single decision tree. And if we are not satisfied with the output of decision tree single model, then how we can use the bagging to improve its accuracy. So all these things we'll be discussing after some time when I will show you Jupyter Notebook and its implementation. These are the steps of random forest. Step 1, here we'll create n number of we are going to use bootstrap sampling to select n number of samples. Then from that bootstrap sample, individual decision tree are constructed for each samples. Each decision tree will generate one output, one predictions, and the final final output will be considered based on the majority voting or averaging for classification and regression respectively. Suppose you are working for a classification problem where we are interested to know the class level, either it may be 1, 2, 3. So in that case, the majority voting. And when we are looking for a prediction model where we are looking for a value, for example, suppose I want to predict the temperature of next day, or or any continuous value, which will be a value continuous from a continuous domain. So it will be the process of regression. So in that case, we are going to make an average of all the value that we have obtained from a single classifier. That's why it is written majority voting for classification and averaging for regression problem. And this is how we can see the random forest visually. So we'll be creating n number of models here by specifying how many model you want to create for a random forest, and each of the tree will be created from a data samples which is created by using bootstrap sampling, and each of the model will give you a class level prediction for a unknown samples, and by considering each of the prediction, we are going to have a majority voting for classification or averaging for regression problem. Based on that, we are going to decide final class or final value in case of classification and regression respectively. Then random forest, here you can see just like previous, here we have another example. Suppose we have an instance of various fruits. It is a problem to identify which fruit it is, and then we are going to create a decision tree like decision tree 1, decision tree 2, and 3. And for unknown samples, we are going to use this tree to make the prediction of class. So, suppose for a unknown sample, tree 1 is saying that it is a apples, and also it is saying that also it is a apples, and and other tree is saying that it is not a apple, it is a. And then the final outcome and the final predictions. So here, as I said, there are two voting scheme. One is hard voting and another one is soft voting. In case of hard voting, every individual classifier votes for a class, and the majority wins. In statistical term, the predicted target level of a ensemble is the mode of the distribution of the individual prediction level. So here only we need to count the numbers, and we can decide which is the majority class. Based on that, the final output will be decided. In case of sub voting, every individual classifier provide a probabilistic value, as I said, for a specific data points belong to a particular class. Suppose we have two class, then we will be having two probability from a single model. One will be representing class 1, another one will be representing class 2. And each of the model is going to give you a pair of positive value, and finally we are going to have the average of that. The prediction are weighted by the classifier importance. As I said, what is the classifier importance? Suppose we have created created decision tree 1, decision tree 2, and decision tree 3. Three decision tree we have created. So here we will not give the importance to a particular decision tree randomly. Rather, it will be based on its performance. For example, suppose you have created 3 decision trees. Based on the training accuracy of decision tree 1, decision tree 2, decision tree 3, we are going to decide its weight. So more accurate model will be having higher weightage, and the prediction which will be returned from each of the model will be multiplied by its weight, and finally it will be sum for sum of all class 1 probability multiplied with its respective weight. Here it will be a value. Similarly, sum of the weight of all classifier into class 2 probability, again it will give you another value, and whichever is higher, suppose for class 1 it is higher, then it will be class 1 as a final output, otherwise it is class 2. For multi-class problem, again the same thing will be happen in that scale. here suppose we have a 3-class problem, then each model is going to have going to return 3 probability value as output. So here baking, here this is the how the overall concept we can understand like this. The simplest way of combining prediction that belongs to the same type. So here baking a approach that will combine the prediction model of similar type. So it may be a collection of decision tree. Here we have seen random forest is a approach of baking where we are combining the prediction model of similar type that is called decision tree. Each model is built independently for a bootstrap sampling, for individual bootstrap sampling, which is created from original dataset. And one decision tree will be built from that, and it will be independent of other model. Different training data subset are selected using row sampling with replacement and random sampling method for the entire training data set. This is what I said, like edge bootstrap sampling. Each model receive equal weight. Here initially each model will be having of equal weights when we are using majority voting. If you are using majority voting with hard voting. If you are using majority voting with soft voting, then we have to here the model will random forest will decide which tree will be having higher weight and which tree will be having lesser weight. And here M is to decrease the variance. So please understand here, when the model, suppose you are working in a machine learning project or data science project for a data set that we have selected, and you have used a model which is having high variance. So in that case, the baking is a right approach to select and to use for that type of project where your model, where your used model is having high variance. And if the classifier is unstable, obviously, if it is having high variance, then we can say it is unstable. So I hope audience know what is the meaning of variance and bias with respect to machine learning model. Then I think this point is clear. Then random forest model uses bagging, as I said here, bagging is a approach, and random forest is a model that uses the concept of bagging. I'll be showing you how we can work on a project, work on a data set where we'll use a base model like decision tree, and if the accuracy is not up to the mark, then how we can increase the accuracy of decision tree by using or the model by using boosting approach. I have Jupyter notebook. I'll be presenting after some time. Next one is boosting. Here the analogy is something kind of like something different. We need to consult multiple doctor, and here when we go for one doctor by another, we are going to use the recommendation which is given by the previous doctor while visiting next doctor. So here coming to machine learning, here again we are going to create m number of or n number of models of similar type in case of boosting, but here the model will not be learned independently. The learning of the model will be dependent. You will see the previous one here. Each model is built independently. Please note here. In case of bagging, each model are separately created and built independently. But here the model are dependent on each other in the sense that a model will be learned from the mistake which is done by the previous model. This is the philosophy of boosting, and how it works. Here the weights are assigned to each of the training samples. So suppose we have 100 number of training samples. we are going to assign some weights to each of the training samples. Well, we are going to use a series of classifiers. Like suppose we have 5 decision tree 1 up to decision tree 5, and each of the decision tree will be added sequentially. Not unlike baking, where the model works parallelly. You can see the diagram there also. Here each of the decision tree works separately, and they works parallelly. It is not a sequential model, but in case of here the model are first thing that they are not independent, they are dependent on the previous model. And here the model will learn from the mistake which is done by the previous model. Initially, the weights will be assigned to each of the training samples. Initially, one decision tree will be created, or one model will be created, and it will be observed that how many data sample are properly classified and how many data sample are missed. The data sample which is properly classified, and the weight will be decreased, and the data samples which is missed by the previous model, in that case the weights will be increased. Why it is so? Because the next model that we are going to use will be focusing on the data sample which is missed by the previous model. So here the weights of each training samples will decide how the upcoming model that we are going to create will see the data samples, how it will give the importance to the data samples of the training samples. So here after the classifier mi is learned, weights are updated to allow the sequential classifier. It is because suppose we have created the first model decision tree m1 from the data. Suppose we have 100 number of training samples. Initially, each of the training sample will be having the similar weight. After the performance of m1 model, some of the suppose 90 number of data sample are properly classified, and 10 number of data sample are misclassified. So in that case, what happens? Those 10 number of data sample which is misclassified, the weights will be increased by some person, and the samples which are properly classified, here the weight either it will be remain same or it will be decreased by some person. That will allow the next model, that is model mi+1, to focus on those data sample which is missed by the previous model, that is m1. Suppose there is another model m2 which is going to be created, then model m2 will be focusing on more on the data sample which is missed by model m1, or the error which is made by model m1. And again the same process will be repeated for m3 will be learning from the mistake which is made by m2. Like that, again m4 will be another model which will be learning from the mistake which is made by m3. This is how the boosting works. And final outcome of the model, that is m star, will be from the combine of the votes from each of the classifiers, where weight of each of the classifier is a function of its accuracy. So how we are going to decide final outcome? Our final outcome will be from the m number of classifier which is created additively. Suppose m1 over m1 we have created another model m2. Over m2 we have created another model m3. So m4. Suppose we have 4 model created, and m2 after m1 m2 has been created. It is not parallel construction. It is a sequential construction. After m1 m2 will be created, and m2 will be focusing on the mistake made by m1. m3 will be focusing on the mistake made by m2, and so on. So after having all the model, how to decide M star? M star will be the final model. M star, final output of M star will be decided from the four model and their prediction, and while prediction, and the weight of each model will be decided. That is based on the training accuracy. As I said, suppose M1 M1 has 70% accuracy, so weightage will be 0.7 for M1. And similarly, M2 individual accuracy was 0.8, so 0.8 will be weightage of M2, and so on. And the outcome will be multiplied with the weightage, and the final outcome will be decided based on the weighted average of the class value in case of prediction, or in case of regression, it will be the averaging of all the value based on their weightage. Boosting algorithm can be extended for the numerical prediction, as I have said. Either we can use it as a prediction model where the class level are given in the form of categorical value, or the prediction can be made for a numerical value. Suppose you are trying to predict the temperature. It may be a value like 34 degree centigrade, 24 degree centigrade. So it will be a value from continuous domain. In that case also, we are going to use the averaging concept. Here, compared to begging boosting tends to have the greater accuracy, but it also risks of overfitting the model to misclassified data. Sometimes there is a chance of overfitting in case of boosting. As I have said, lastly, when we use begging will be helpful when we'll be having a high variance case. To lower the variance, we can use begging. But in case of boosting is focusing on bias rather than variance. How can we define bias? I think you know more or less. Bias is the thing how the model output skewed to the ground truth. Means how it differs from the ground truth of the given ground truth. In that case, means what we can say, if it is a higher bias, then low accuracy. And here, if we have a model a case of higher bias, in that case we can use boosting to make the bias low and get the accuracy high. As I have said, we cannot have a model having both lowest variance and lowest bias. We have to select the trade-off to have the balanced bias and variance. So this is how the boosting can be seen pictorially. So here, given the data D here, we are going to create a model M, and here, then when we create another model, this one, and that model will be focusing on the changed data D dash. Here, earlier dataset will be having all sample will be having equal weights. Here the weight will be decreased or increased based on the classification, proper classification or misclassification. Then again we are going to create another model, this M2. Again the data and their weights will be changed. Data samples along with their weights will be changed. Again we are going to create another model based on that data, and sequentially we are going to add one model on another. And the final outcome will be decided by having the prediction from each model and their weights. And this is the algorithm, as I said. Here, tuples. So here, what we'll do? We'll create a data samples from the original data set. Each tuples will be having equals weights. Means we are giving equal opportunity of the each of the tuples. A classification model MI will be derived from the data sample DI. Then its error is calculated based on the misclassification and the and proper classification. If a tuple is misclassified, then its weights is increased, or the weights is decreased if it is properly classified. The final error will be calculated based on the weight of the model. Weight of the data samples, and the error which is happen in that particular data sample xi. xj. Wj is the weights associated with xj where the error is made. Then all those data samples where the error will be made, we are going to collect their weight, and the sum of the weights and the error will be the final error of the model. And weight of the classifier mi vote will be calculated by using log likelihood estimation, log of 1 minus error mi divided by error mi. It will decide the weight of the classifier, how it will be changing time to time. This is how we can see that adaptive boosting, how it works. Adaptive boost is one approach that is adaptive boosting, which is using the boosting concept. This is the first model developed which is based on boosting. Although there are other boosting techniques like light boost technique, gradient boosting tree, categorical boosting, that is cat boost. So here this presentation will be focusing on basic boosting model, adaptive boost. Here, how this picture demonstrates how the weight will be changing over the period of time from the data set. Suppose we have a original data set D. From D, we are going to create a sample of the data D1. Suppose this is the representation how the data samples are there in the space. And see here, it is a two-class problem. Here plus minus represents the classes of each data samples, and their size. Here the size of plus and minus almost they are equal, and they represent their weights. So initially plus and minus all actually what happened is there will be a data sample like this. There will not be any boundary like that. So it will be a simple data sample like this. Minus, then plus, and up to. There will be no boundary like this. And each of the symbols, each of the data sample will be having the same weight. That's why they are having the same size. Size represents their weights. So here the first model will be created. First decision tree will create a boundary, decision boundary. Suppose that decision tree created a decision boundary like this, means anything that appears left to this is plus class and right to this is minus class. So suppose we have created decision tree 1. Based on that, we have created a decision boundary like this, and we can see that these two are properly classified, but some of the misclassification done on right hand side of the decision boundary. Here in this case, you can see that these 5, 1, 2, 3, 4, 5 data sample are properly classified, but these 3 data sample which are supposed to be and the left of this decision boundary now, but they appear in right hand side of the decision boundary. So here this is where the misclassification done by decision tree 1. So what will happen now? Based on this performance of decision tree 1, we are going to change the weight of the data set of D1. So from D1 we are going to create D2, another data set. In another data set, how the weight will be changes, Now see here, in this case, we are going to increase the weight of this misclassified pattern. So now you can see here, we have increased the weight of this 3 plus big, and for the representation, we have created a big plus as compared to previous plus. Yeah, size is bigger. So and size decide the weight. Now the next decision tree that we are going to create will be focusing on the data sample having higher weight, and it will try to create the decision boundary in a such a way that this these data samples which were previously misclassified will be classified properly. So based on that, suppose we have created another decision tree 2, and decision tree 2 decide the decision boundary like this. In this case, the anything right to that is the negative class, and left to that is the positive class. So in that case, what happened? These two data sample are properly classified, but here these three data sample which are supposed to be right hand side of the boundary, now that they appears in the left hand side of the boundary. This is misclassification. So next time again from D2 another data sample D3 will be created. In that case, the model will decrease the weightage of will increase the weightage of those misclassified data sample in D2. So next time the weightage of this minus and this minus will be increased. Now you can see here. Then next model which is going to be created D3 decision tree 3 will be focused on those data sample which is misclassified. Means the priority will be here on this data sample to make it properly classification. So in this case, the suppose decision tree has created this decision boundary. So down to this is the negative class, and up to this all are the positive class. So in that sense, so here these three are properly classified and one is misclassified. Here down to that these four now 1 2 3 4 now properly classified, and these two are the misclassified. Again, based on that, we can create another decision tree 4. D4. Another D4. We need to increase the size of those sample which is misclassified in decision tree 3. Means here in this D4 there will be the higher weightage for this plus, and this minus, they appear on the right on the top. So in this way we are going to create the decision tree one by one, and final predictions will be made. So here it is your M1, it is M2, it is M3. Then now how we are going to decide M star? M star will be the combination of M1, M2, M3. Now look here, we have combined the decision boundary of M1 here. This is the decision boundary of M1 we have taken from M1. This is the decision boundary of M2 we have taken from M2, and this is the decision boundary of M3 that we have taken from M3. Now here this will means this represent a region of decision boundary. Now the blue portion will be deciding the positive class, and the red person will be deciding the negative class. This is how the additive boosting works. So this is the point we need to remember about boosting. Here new models are influenced by the performance of the build model, previously build model. This is the difference from the baking. In baking, all the model are trained separately and independently, whereas in case of boosting, the models are dependent on the performance of the previous model. And here the second thing is that the models are weighted according to their performance. Here, based on the performance, we are going to give the weightage to the models. Here, aim is to decrease the bias, as I said, not the variance. When we are dealing with variance, we need to go for bagging approach. But here, when we are dealing with bias, suppose we have a model, suppose you are working on a data mining or data science project, we have created a model which is having high bias. In that case, we need to go for boosting. Every new dataset contains the element that were misclassified by the previous model. So this is how we are going to select the subset of the data samples. Each time we are going to create a model based on the performance of the model, we are going to change the subset, and we are going to create a new subset based on the previous model. We are going to either increase or decrease the weight of the data samples, and the next model which will be focusing on the data sample based on the new calculated weights. In the base classifier here in this model, base classifier are trained sequentially. In this approach, the base classifier are trained sequentially, means it is not parallel or independent creation of model. Here we are going to create the model sequentially. The AdaBoost uses the concept of boosting technique. Boosting is the approach, and AdaBoost is the model. Adaptive boosting is the first model created based on the boosting approach. Next type of approach is called stacking. We have covered bagging and boosting. Next one is stacking. Stacking is appropriate when the multiple different weak machine learning model have the different skill. Suppose in this case, suppose you are working in a machine learning model as project where already we have used a concept, we have implemented bagging and boosting. Still it is not working. Still the performance that you are looking for, we have not achieved. Then we have another option to go for stacking, where we can use multiple different weak machine learning models. So in this case, we are going to choose the model which will be of heterogeneous type. How can we say the model is heterogeneous? Here, if the model is having different way to create the model. For example, decision tree has a different approach for model creation, which is different from naive Bayes model. In case of naive Bayes, it is a probabilistic model, whereas a decision tree is a entropy based model. Here we can say decision tree and naive Bayes are heterogeneous model. But when we compare decision tree and the random forest, they are, we can say the homogeneous model. They both are entropy based model or tree based model. So here stacking, whenever you are going for stacking, we need to select the model which will be of heterogeneous type. So how stacking works? So from the given dataset D, we are create samples of the data samples. Then each of the model will be trained separately. Model 1, model 2, model 3, model 4. Suppose here we have used decision tree. Here we cannot use another decision tree because it should be different machine learning model must have their different skill. So here it may be another model called linear regression. It may be an naive Bayes. It may be a KNN. So we are going to use different types of prediction model to implement stacking. So here for each of the data samples, we are going to create different type of model separately. Then we are going to have a prediction on prediction from each of the data samples, and from the prediction of each of the model, we are going to create a meta learner. Meta learner, here we are going to use another model. For example, suppose here we are using logistic regression. Logistic regression, here we are using means from the outcome, from the prediction of each of the model, we are going to create another data samples. From that data sample, we are going to train another model which is called meta learner, Meta-learn is a model which will learn from the prediction of the another model. So here logistic regression is going to learn from the prediction of decision tree, from the prediction of linear regression, from the prediction of naive Bayes, from the prediction of KNN. And that once we'll construct the meta learner, then final output will be from the prediction of the meta learner. So I have another slide to explain it more clearly. Here, let us say example here. Suppose we have a data set like this. This is the original data set X or D. This is the original data set D. Here, this person represent the input, and this is the target. From the D, we have created a training data samples. This is the training data sample, and this is the testing data samples. Xtrain is the contain all the input attribute along with their data. Ytrain is the class level of the training samples. Similarly, Xtest is contain all the training samples with their training input attribute, and Ytest all the training sample with their class level. Sorry, a testing sample along with that class level. So from data sample D, we are going to create a training data sample, this, and we are going to create any kind of fold. It may be 5-fold, it may be 10-fold. So for example, we have created 10-fold. So here this fold is having some of the training data samples along with their class level. Second fold is also having some of the training data sample along with their class level. Then here this training data samples, whole data sample will be used to train a model, for example, a linear regression. Here the same data sample will be used to train naive Bayes. Same data sample, training data sample will be used to train LDA, DT, MLP. These are the various models that we have used. Then we are going to have a prediction on the training data. Vimal sir, am I audible? Hello. Any participants? Please respond. Am I audible? Hello. Hello.
Yeah, hi, sir.
Hello.
Yeah, Vimal.
Yes, sir. Am I audible?
Yeah, we can hear you. We can hear you.
I thought I got disconnected.
No. We can hear you. The session is going on.
Okay. So from here, how the stacking works? From the original data set D, we are going to create two data, one for training and another for testing. From training, we are going to build various base classifier. We are going to construct base classifier like linear regression, naive Bayes, LDA, decision tree, MLP, like that. And we are going to have a prediction on the training data sample. So see here, look here, TP1 is the prediction of LR. Similar to that, TP2 is the prediction of naive Bayes. What the TP1 contain? TP1 will be a vector containing the predicted class level of all the training samples. Similarly, that TP2 will be having a vector which will be the prediction outcome of nav base. TP3 another vector, a vector of prediction from descent with LDA. TP4 is the prediction of descent tree, and TP5 is the prediction of MLP. Then we are going to create another data set. It will create another data set which will be having the prediction of TP1, TP2, TP3, TP4, and TP5 as an input. So here we are going to create this column for TP1, TP2, TP3, TP4, and TP5, and this is the white trend from where we will get the same white trend which was available in training data sample. It will be again taken here. This is how stacking works. Then it will create another data samples. This will treat it as another data sample where the input are the prediction from all of the base classifier. So how many input, how many column will be there here? There will be 5 column, that is the prediction from 5 classifier along with the white trend taken from the training data samples. So there will be 6 column. Now this will be treated as a new data set. Here these are the input and this is the output. Then from this data we are going to build a regressor. Here here we can use a logistic regression model where the input will be, this is your input and this is your output. Based on that we are going to train the model. So once the model is trained, then this model can be tested by using the testing data that we have created from the original data set. Now from the testing data we are going to check how much that meta learner works. This is called meta learner. Meta learner will take the prediction as an input from the base classifier, and it will be learned from the prediction of the base classifier. Then once it is learned, then we can test it by using the testing data set, and based on that we are going to decide the performance of the stacking ensemble prediction. This is how the stacking works. But here we need to note that while selecting models, be sure that we are not using similar type of machine learning model. They works on the same strategy. So by using stacking, we can overcome both the problem of variance and bias. Why variance? Because we are taking the help of various models. And why bias is that the meta learner is also learning from the prediction of the other base classifier. That's why it will take care of bias as well. New model are new model are influenced by the performance of the previously built model. How? Here the previously built model are this, and from the previously built model, whatever prediction we have, from that prediction the meta learner will learn. So here indirectly meta learner is learning from the mistake which is made by the other learner, base learner. Here we have two level of prediction. Why? This is the first level of prediction made by the base classifier. Then it is the next level of prediction where the final prediction will be done by the meta learner, which is learned from the prediction of the base classifier. Then here mostly here aim is to decrease the bias, not variance, but we can deal with the variance in the sense we can choose the trade-off between bias and variance. So as I've said, we cannot have a model with minimum bias, minimum bias and minimum variance. This is a contradictory requirement. So in that case, we can choose the both both bias. We have to choose the model based on the trade-off between bias and variance, which meets our acceptance criteria. In the base classifier, in here base classifier are trained separately and independently. Like begging, here also the base classifier are trained separately and independently, but the meta learner learn dependently, which is dependent to the base classifier. Now, I'll be moving towards the implementation of this. First of all, we'll be discussing how to implement a decision tree classifier for a selected problem. We'll observe how much accuracy it is giving. Then we'll go for the implementation. Then we'll go for the implementation of begging to improve the accuracy of single base classifier. Then we'll try to understand the output of begging, how we can visualize the different number of tree which is created during random forest construction, how to understand the output of a random forest. Nowadays, due to the development of Pythons and other libraries, that became easy to implement all these models. But the question is how much we are understanding the output which is given by the model. How we can visualize the inside of the model. It may be random forest, adaptive boosting, and other kind of things. So here I hope my slide, my next presentation in Jupyter Notebook will be helpful for you to understand that. Up to I think it may help up to some level. So next one is the implement. Next we are going. Next I will be showing implementation of boosting. Here in this case, I will be discussing adaptive boosting for data classification, and again how to visualize and how to understand the output of boosting. Then we'll be going on implementation of stacking algorithm for data classification, and also followed by understanding the output of stacking. How we can understand. Then at the end, I'll be discussing some point on how do we optimize the various type of hyperparameter in case of ensemble learning. Ensemble learning also could be improved by using some kind of hyperparameter optimization. And here the question is, what are the parameters that we can optimize in case of ensemble learning? We'll be discussing. Then I'll be discussing on various type of hyperparameter optimization a strategy that can be applied on ensemble learning. So here I will take the help of Google Colab, and I will run Jupyter Notebook that I have created. Sorry, my system is taking uh, more time than expected. Okay, this is the things. Okay, here this is the top. These are things to be covered. I will show you first the implementation of dysentery for a particular problem. Here, we can use Epsilon lab, a package where we have a dysentery classifier. Before that, before that, we need to import the necessary differences like uh, pandas and Python. Let me run the cells. Then once it is done, we can download our, we can upload the dataset. Here I have selected, I need to select the diabetes dataset. So let me run to import the files. Here by this way I can import, I can select the dataset that is there in my drive. So here dataset is uploaded. So here I can fetch the data and I can see the safe. So here the dataset is having 168 row and 9 number of attributes. I can read some of the data samples by running the code data.read 5. It will show me first five data samples from the data set. So data set is like this. We have various input attribute like pregnancy, glucose, blood pressure, and thickness, insulin, BMI, age, and this is your outcome. Outcome says that whether it is a diabetes patient or not. Then here, let us split the data. Let us make the input and input attribute and the class level separate. For that, I have to run this code. Then I can see the dimension here. I can see the shape of X here. Now the shape of X became 768 as an 8. 8 is the input attribute. I have made the class level separate and I have saved in Y. Y is the target. And here also I can check the dimension of Y. There is a one-dimensional array having 768 number of row, and this represent the class level of 768 input data samples. Then here you can visualize complete data in X. So X will be a multi-dimensional array. This, and Y can be seen as a vector of all class level representing 1 0 1 0. Then we can create a decision tree classifier. Let us assume that you are working on a data science project, and you are acquainted with the decision tree. So we can create a decision tree. You can import it from sklearn, and we can instantiate a decision tree like this. So here I have not mentioned any parameter of decision tree. It will take the default parameter. Then I will train the decision tree. Then after that I can predict with some input attribute. Here it is the input that I'm giving 8 number of input based on the 8 attribute in the of the diabetes data set. I can give this input and I can predict the output. So if I run this, then here what it is saying that here it is printing that diabetes 0 and it is 1 for this type of input data samples. So here we can have a generalized performance by evaluating model by using k-fold cross validation. In that case, I have created a 5-fold. I have created 5 split. I'll be having 5 accuracy of each fold. So it is showing that the accuracy is like this. You can see that it is 0. Sometimes it is giving a 0.70 means 70% accuracy. Here it is 58% accuracy, 74, 80, and 1073. Here we can see that, and we can say that this is a model having higher variance. Here, sometimes it is giving accuracy of this, and sometimes it is giving accuracy of around approximately 60, less than 10% accuracy, kind of thing. And average accuracy is like this. Suppose now you want to improve the accuracy of the model that you have used now. So here, let us see how we can improve the accuracy. We can see that the accuracy is not up to the mark. Also, there exists high variance in the performance of the model. So in this case, we can use a bagging approach. Now we will see how we can implement bagging, which is called random forest model. So here, this is a random forest is a classifier which is there in sklearn package, and then we can import it. We can instantiate random forest here. Here it will take the parameter like number of estimator. Means here it shows that how many decision tree you are going to create. So by default it is 100. And after that it will here it is another parameter for what type of entropy you are going to use. As decision tree is an entropy based method, you can use Gini, you can use information gain and other option. Then we can train the model. After training the model, we can predict the class level of the unknown data samples. Let me run the code. Now for the same data sample which was earlier, which here it was 0 and 1. Now our random forest is saying that it is 1 and 1 for the same data samples, input data samples. Now we can evaluate the random forest by using k-fold cross validation, and this is the code I have written for it. Here I have taken the model section from sklearn. I have calculated cross validation score. This is how the random forest is giving output: 74, 70, 78, 84, and 73. This is how the random forest is giving output, and average accuracy is like this. But if we compare the previous one, where the variance was approximately 10% from one accuracy to another, here the variance is not so much, and also the average and accuracy is also high as compared to advanced tree, as compared to a decision tree. Look here, it was the variance, and you can see the variance here approximately 10%, and overall accuracy is also less. It is 71. But here in this case, variance is also low, and accuracy is also high. So now, how we can understand the output of the random forest? Here, let us see how the tree created, and here, if I run this, what we are trying to do here is that we are trying to print the random forest, and we are interested to know what are the tree which is created inside it. So here, random forest that we have created here earlier. Here we have not mentioned the depth. Depth is another parameter which is there in case of random forest. If you are not mentioning depth, it will take the default depth of the tree. So based on that, if I print the first tree which is created in the list. See here, in case of random forest, the default estimator number of estimator was 100. It will create 100 number of tree inside it. And so, and suppose I am interested to see the first decision tree in the list, and it will be stored in a random forest estimator 0. Estimator start from 0 to 99 in case of 100 number of estimator. So estimator 0, it will print the first decision tree which is created in the list of decision tree. So and to print, I can run this type of code, and now you can see this is the decision tree for Sorry, this is the first decision tree created in the list of decision tree for the random forest. So again, here we can see it is very difficult to read. So let us make it readable. So let us change the depth of the RF estimator here. So let us know what is the default estimator here. See, default maximum depth here in this case it has taken 18, depth of 18. So here the estimator, the first estimator, the first decision tree in the list of decision tree has a depth 18. So let us restrict the depth to 3. So in this case, again I have to re-instantiate random first classifier. Here in this case, I have mentioned that maximum depth it can go up to 3. So let me run the code. Now I can see what is the maximum depth it has now. Now this is 3. Then here I can see I can visualize now the same thing here, random forest. Then let me do it. So now I'm trying to visualize the first decision tree in the list. Now you can see it is readable. Now this is the first this is the first decision tree created in the list of decision tree of the random forest. Now how we can understand this? Now to understand this, let me show you the data. This is the data from which we have created the decision tree. We have how many input attribute? 8 input. 1, 2, 3, 4, 5, 6, 7, and 8 input attribute and one class level. Right? Now this represents all the input output stored in X, and outcome, that is the target, is stored in Y. Right? Now the frequency, this represent the first column, that is X of 0. Glucose represent the second column, that is X of 1, and this is X of 2, and so on. Now what it says, X of 6 is less than 0.71, means which one that is? 0, 1, 2, 3, 4, 5, 6, this one. If the diabetes pedigree function is less than 0.71, then it will go to the left side of the tree, otherwise it will go to the right side of the tree. And what it says, Gini equal to 0.5. How Gini is calculated? Based on the overall entropy and the entropy in the split. This is based on the theory that is the information theory, and those who know about decision tree construction and the attribute selection, they may get it very well. So here, if you are not, please go through to the construction of decision tree, and then these things will be more clear. Then again here, go to the left. Again, it is using the fifth attribute, that is X of 4, and with a condition, if it is less than this, then it will go here. What is the fifth attribute? This one, insulin. If insulin is greater than less than equal to 217.5, then it will go to the left, otherwise right. Now this is the decision tree that we can see in the list of decision tree, and this is the first decision tree in the list. Similarly, you can see the second decision tree in the list. This is here. You can see the second decision tree in the list. That's why it is estimator 1. Here you can see it has a different set of attribute selection. Earlier, the first decision tree, the root was X6. Now the root is x0. Now the root is this one, pregnancy. Pregnancy is the root. Previously the root was uh, diabetes pedigree function was the root. So it will select the attribute by using random selection, and it will evaluate each of the split by using Gini. So then here here by default, as you know, how many estimator it will create? 100. So suppose you are interested with 50 number of estimator, then you can mention their estimator equal to 50. So here uh, by default it has created how many number of estimator? That can be printed by using length of RF estimator is 100. Similarly, you can print the last estimator in the list, that is random estimator 99. 99 is the last estimator in the list of 100 estimator 100 decision tree. If you run this cell, then it will show you the last decision tree in the list. And like this, how many decision tree? 100 number of decision tree they are in the random forest that we have created. Similarly, we can go for the implementation of adaptive boosting. Here, as you know that adaptive boosting technique is helpful to deal with the bias, high bias case. So here, now we'll check how the adaptive boosting is performing on the same problem. So here I have imported necessary dependency, necessary package, and necessary model that we are going to use. AdaBoost is coming under Scalon and symbol. So I have imported here. Then here, in case of adaptive estimate, the adaptive boosting classifier, we are going to use a base estimator as a decision tree. So each time a decision tree will be created sequentially. This is what we want, and that's why we have written we have instantiated AdaBoost classifier here, along with base estimator decision tree classifier with number of estimator 100. And here we have trained the model AdaBoost classifier. Then we can use that to predict the unknown class samples. If we run the cell, then here the output is like 0, 0, 1. So if you want to know the overall performance, then we can run the cell. We can run k-fold cross validation, where I have created 5 folds, and see here the output is like this, which is also not so good in this particular data set, and it is around 0.70. Here the model may behave differently, but to avoid this, you can set here a random state. Then here also we can see the different type of tree that is created in AdaBoost classifier. Here it will take the help of 100 number of classifier. Similarly, you can print the first estimator. You can print the first estimator, then here in this case it is hard to visualize. So the same thing, you can reduce the depth to a particular level. Let's say it is 3. You can restrict the depth to 3, And here I forgot to mention here. There may be question in your mind. This is not a good accuracy, but we are claiming that Adobust will perform better than begging and other single model. But here, as you see that we have a different type of estimator and see the different type of hyperparameter that is associated to uh, Adobust classifier. So here, but here I have used the base. I have used the default parameter. You can adjust it accordingly. You can use what type of information measures, what type of selection measures it will choose, like Gini or information can you can select. Based on that, we can optimize the performance of Adobust classifier. So we can set it to 3 to better visualization. If we set it to 3, then it will be having a model with maximum depth 3, and it will run the cell. And this is the first tree you can see of depth 3, 0, 1, 2, 3, and we can read this in the similar way that we have done in random forest. Similarly, you can print the last estimator and then the name. Previously, I had run the cell, that's why the output was there. And this is the last estimator. Similarly, you can see how many estimator in the list. It wasn't there. Now you can see how we can implement stacking. So stacking will take the help of multiple dissimilar classifier. So here we have 3 classifier: KNN, nav base, and decision tree. And we are I am trying to create a stacking ensemble learning, which will use the base classifier as k nearest neighborhood, Gaussian nav base, and decision tree. And I have planned to use logistic regression as a meta learner. That is the prediction of the last level. So here what we have done. Here we have evaluated each of the models separately. Here it is the evaluation of KNN. This is the evaluation of Gaussian nav base. This is the evaluation of decision tree. And now here I have created a pool of estimator. Like here we have 3 estimator I have used: KNN, Gaussian nav base, and decision tree. Then here I have instantiated stacking classifier, which parameter is the estimator. That's why I have created a list of estimator here. Then the final estimator, which is the meta learner we have used, is called logistic regression. Then what will happen here? It will use these 3 models separately, and it will get the prediction of each of the model, and that model will be the input to the stacking classifier. The prediction of this model will be input to the stacking classifier, and based on that, one logistic regression will be created, and it will be trained. And here it is the final evaluation of. This is the final evaluation of logistic meta learner. That is stack assemble classifier. So let me run this. Now you can see how individual model are performing, and what is the final output of this. Here KNN has a average performance like this. Gaussian nav base has a average performance like this. Decision tree has performance like this, and stack assemble learning has a performance like this. which is mean average of 76, around 76. So this is how we can improve the. You can remember that decision tree, it was giving a accuracy of approximately 70%, and by up to this level we have achieved 76%. Still, we can improve the accuracy in a better way. In that way, we can use the help of hyperparameter optimization. Hyperparameter are the parameters that are associated with a model that cannot be learned uh, by the model itself. There are two things. There may be confusion between parameter and hyperparameter. Weight is a parameter in case of neural network, but that is not the hyperparameter. Learning rate, the number of layer in the neuron, number of layer of a neural network, how many neuron of each layer, and that parameter will be known as hyperparameter. That cannot be decided by the model itself. We have to decide as a coder. We need to decide how many number of layer would be there, how many number of neuron will be there in each layer, what type of activation function you are going to apply in each of the neuron in every layer. These are this selection are called hyperparameter selection. But the weight of a neural network is the parameter which is learned by the model itself. That is only the parameter of the model. That cannot be hyperparameter. Coming to ensemble learning model, we have various type of hyperparameter associated to the model. So now let us try to understand what are the hyperparameters associated to adaptive boosting. Adaptive boosting, that is the AdaBoost classifier. We have various parameter like base estimator, which is the base estimator we have selected. But we have selected decision tree. Also, the number of estimator, by default it is 100, but it can range from 10 to 100. We can have a number of estimator below 100 also. It may be 60, it may be 40, it may be 20. Now question is, which number of estimator is the optimal number of estimator for the AdaBoost model. So now this is the problem to understand. Now learning rate, what will be the learning rate? Learning rate in AdaBoost is to control the weight, how the weight will be changing time to time when we are adding the model sequentially. So the learning rate controls how the weight is going to change. So these are the number of estimate hyperparameter we can control, we can manipulate to get better accuracy. Now hyperparameter selection could be done in many ways. It may be manual search, it may be grid search, it may be random search, it may be automated hyperparameter tuning, where you can use Bayesian optimization and genetic algorithm. So this requires some extra things that is associated to like here computational intelligence and other concepts, natural inspired computing and all. But here we can discuss manual search, grid search, and random search. Manual search is a process where you can select and give the input manually. Suppose you are not interested to give 100 number of estimators by default. You can set it to 30, check it how it is giving. And next time you set it to 50 and check how it is performing. So hyperparameter combination could be many things. Suppose for the instance, let us consider only two things: number of estimators and learning rate. So learning rate, the number of estimator can be ranged from 1 to 100, or you may be exceed also, and each time it will be increased by 1. This is I have set here. And learning rate can change from 0.1 and it will go up to 2. Means it must be set between 0 to 2. and each time it will be changed by interval of 0.1. So based on this, it will create possible combination of number of estimator and the learning rate. So one combination could be the number of estimator is 100 and learning rate is 1.2, and another combination could be number of estimator is 50 and learning rate is 20. So here it will evaluate each of the permutation and combination that could be possible for the hyperparameter, and it will select that hyperparameter combination that will return maximum accuracy. So for that we can use a manual search, which is a tedious process, and another one is called grid search. Grid search, where we will create a grid of that hyperparameter value, and each time one combination will be tested and evaluated, and based on that the final optimal hyperparameter set will be returned. In case of random search, here it will start some random combination, not all possible combination. It will start from some random combination. Unlike grid search start from all possible combination. It will consider all possible. It will evaluate all possible combination. Here it will start from few random combination, and and gradually it will explore other hyperparameter space. And similarly, we have a Bayesian search, which is a probabilistic method. It will focus on those hyperparameter space which is having potential a possibility to give more accuracy. So based on that, it will use the concept of Bayesian theorem and Bayesian concept, Bayesian probability concept. Genetic algorithm, each time it will create it will start with the population of hyperparameter possible combination. Then the fitness will be evaluated in the model. Then based on the fitness, again crossover, mutation, all the things that will take place. So here in Python we have the advantage of grid search. It is available grid search, that is grid search CV. We can perform directly grid search CV. For that we need to create the parameter grid. So here I have created two things. One is number of estimator that range from 1 to 101, and estimate learning rate will range from 0.1 to 2. So it will evaluate the possible combination and show you the best combination. If you run this, then here for this selected things, here number of estimators, it has selected 92, and learning rate is 1.8. For this, the maximum result it has obtained is 0.699. So this is way, but here we have considered only two hyperparameter. In fact, AdaBoost model has more than 10 hyperparameter in the list, and you can include one by one, and you can get the better accuracy. Similarly, we can use. Sorry, here I have run random search here. Sorry, we can have grid search as well. Sorry, I think I have deleted this unknowingly. So this is how grid search, and then Bayesian search also. We have Bayesian search by using that things, a number of estimator. I have this. I will share this slide for your reference, and you can see how the things it's happening. And this is for genetic algorithm. And if you run this, then you will get the better performance, and also you will be able to know what are the hyperparameter list which is optimal for the ensemble learning model. Coming to the slide, sir, Vimal sir, how many time I have left?
Yeah, we have time till 30 minutes, 20 minutes more.
Okay, sir.
Okay. And we will
Then,
share all these resource material to participant as Kyle will
yes, sir, yes, definitely, I will share.
when you
I need to
once the
update.
session is done, you share me the file and we will send to the participant. Okay.
Yes, sir, yes, sir. Actually, sorry to say that some of the things that I have had deleted while editing the files.
Okay.
So I will edit. A grid search is missed here. So I will
Okay.
add the grid search person and then I will share it. Then
Yes,
it
please,
will be
please.
completed.
Once everything is done and you are free, you please formulate it and send it. No issues. Thank you.
Okay, sir. Okay, sir.
Okay.
Thank you.
Please proceed.
Then your conclusion. Now, when to use ensemble learning? Here to get improved performance and to get a stable model. While working in a machine learning or data science project, creating a model, if creating a single model is not sufficient to get better accuracy, and if you are not satisfied with the performance of a single model, then go for ensemble learning approach, uh, which will give you better performance and a stable model. Breaking, in general, you can say it is a homogeneous model trained independently. This deals with high variance case. Boosting, it is also a homogeneous. It is the collection of homogeneous model trained dependently. Dependently in the sense, model are one model will learn from the mistake of another model, and it deals with higher bias case. Stacking model is a heterogeneous trained model is a collection of heterogeneous model trained independently, but the final estimator trained dependently. So it is the stacking is a combination of both dependent and independent learning. So in first level of learning, it is independent of each other, and in the final level of learning, in case of final estimators, it is dependent learning, and it also deals with higher bias. Computational complexity, yes. You may ask this that obviously whenever we are creating a single decision tree and another hand we are creating 100 number of decision tree, then obviously the computational complexity issue will be always be there. So everything comes with the word with merit and demerit. So if you are running with less resources, then in that case ensemble learning approach may not be suitable for us for you. So if you are having a good resource computation, then you track for ensemble learning model, which will give you better accuracy. If you are updated about the recent Kaggle and KDD competition, you might have heard that XGBoost and all the boosting approach came to the picture from that type of competition. They have won many competition, data science competition, all particularly the boosting algorithm. I'm talking about XGBoost, CatBoost, line gradient boosting. They are the good model. But here, obviously, there will be the issue with computational complexity. It will take larger time, larger space, and which is both means time-wise and complexity-wise, space-wise, higher than normal ML models. Thank you, sir, and thank you, participants, for kind hearing and patience hearing.
Yes, the session is open for queries. And participant, if you have any queries, you can use the chat box or you can raise the.
You can ask directly also.
Yes. Actually, yes, you can raise your hand and we will mute it. So no issues. And Nayak sir, the ensemble Nayak is very strong person in working in ensemble. Most of his research papers are done in bagging boosting approaches, and his scholars are really working in this domain and strong scholars are working in this domain under him. So ensemble is a leading techniques which are providing very strong approaches for your applications. So you can work on ensembling techniques, and very few papers are available in market in ensembling area. I think my preview is correct. I think Naik sir, let me know your suggestion also.
Mm. Yes, sir. Yes, sir. Actually, uh, if you're looking for any type of competition that are happening in KGL or any data science competition, you can see that this boosting, particularly boosting approach, has a remarkable performance over last 5 to 6 years, and also many modifications are taking place in boosting approach. And now if you're looking for competition, then it is fine. If you're looking for papers, research papers, and all, then in that case, again, only applying this kind of ensemble learning directly, like using random forest, using Adapt Boost, will not work. We have to make it larger by applying other type of integration, like we can use optimization, we can use a higher level optimization to get a better accuracy for ensemble learning technique, particularly boosting. We can play with various type of hyperparameter selection, uh, various kind of tools we can have to in that way we can have a better.
Yes. And the XG boost model, it is also one of the very good techniques. And any weak classifier we can use and boost it, and that is very strong areas. Many researchers and very few researchers are working in this segment and publishing papers. So Nayak is one among that good researcher. So he is open to all. Anytime you can commit with him, and he is a very good human being. Apart from that, he is ready to help always.
Thank
His
you.
scholars are very blessed. That is my point of perception. Whenever we work with BNayak, scholars are very much blessed to have such a supervisor like him. So whatever the queries or whatever the point of research, anybody can communicate with BNayak sir. He is open to all. So with this small few note, I think there is no questions raised in chat box also. Okay. Okay, so thanks, Naik sir, for the last 3 hours you have spent with us, and you have given some
Thank
valuable insight about the ensembling techniques. It's been a great time to have you for today's session.
Thank you, sir.
Apart from
Thank you,
your,
sir. It's my opportunity to join with you, sir. You are
yes,
you
sir.
are you are Yes, sir. Yes, sir.
Yes, yes.
Uh,
So
so should
thank you
I
once again.
stop sharing, sir?
Yeah, yeah, you can stop sharing. And thank you once again for Naik sir for spending the time and giving his presence for today's session. So with this thank note, we like to conclude the forenoon session. And, we will post the feedback in chat box, and the participants can complete the feedback. Yes, it is posted, and you can complete it. And B Naik sir, thanks for your presence. Thanks a lot. We will discuss in another occasion. Thank you. Thank you very much.
Sir, sir. Sir, welcome, sir. Thank you.
Yes,
Thank you for
yes.
the input.
And the participants, you can connect for afternoon session by 1:50 p.m. So we have another resource person, Dr. Saroj Meher sir from Statistical Institute, Bangalore Center. So please feel free to fill the feedback form, and you can connect by afternoon session. Thanks to all. Thanks, Nayak sir. Thank you very much. Thank you.
Thank you, sir.
Meher sir, good afternoon.
Yeah, good afternoon.
Yeah, sir. Another 3 minutes, sir. Our
Yeah,
participants
yeah.
are joining
Okay,
now.
no problem. No problem. No problem.
Okay, sir.
My voice is clearly audible, I think.
Yeah, very clear.
Okay, okay.
Okay. Saroj sir.
Yes, sir.
Meher sir, can you hear me?
Yeah, hearing.
Yeah. So we will start with a short bio about you, and we can directly get into the session, sir.
Sure.
Amuza ma'am. Okay. So very good afternoon to all the faculty community members and all the participants. Today we have a eminent resource person, Saroj K. Meher sir. He is an associate professor of system science and informatics unit at Indian Statistical Unit Bangalore Center. He has received a BSc degree in physics and honors from Sambalpur University in 1990 and is an MSc degree in physics with electronic specialization and PhD degree in science from NIT Roorkee. He has completed around in 2003. He worked as a senior research scientist at R&D units of various industry in India for about 3 years. He was awarded many times for his excellent contribution to various critical projects. He worked as a postdoctoral fellow and visiting assistant professor at Indian Statistical Institute, Calcutta in 2005 to 6 and 2009 to 10. He received Sir J.C. Bose Memorial Award of the Institute of Electronics and Telecommunication Engineers, India in 2003 and Orissa Young Scientist Award for Research in Electronic Sciences and Technology for 2003. He is a senior member of IEEE since 2011. So his current research interests include image processing and analysis, remote sensing imagery, pattern recognition, granular computing, domain adaptation, adversarial machine learning. He has contributed about 80 research papers in well-known and prestigious journals. He has supported many international referred conferences and acted as many resource person towards it and edited a monograph volume. He has completed one granted US patent and it has been done in the year 2015. And we are very glad to have Dr. Saroj K. Meher sir. He is an eminent person who is working in this domain for so many years. And he has produced many strong research scholars under him. And currently, many scholars are doing their PhD and postdoc under his guidance. We are very much happy to have you for this session for today, sir. So, we are privileged to welcome you for our session. Welcome you,
Thank
sir.
you, Dr. Kumar. So my slides are visible.
Yes, sir. Yes, sir. Please maximize the screen, sir.
Okay. Now is it visible?
Yeah, it is visible, sir.
Okay.
Yes.
So thank you for this nice introductions. Uh, so before I start, I should thank the organizing team for giving me opportunity to share my research experiences with you all. Uh, can you please tell me how much time I am allowed to speak?
Yeah, afternoon session until 4 p.m. We have planned for all days, sir.
2 to 4, right?
Yes.
So it will be in a stretch or there will be any break?
Without any break, sir.
Okay,
Directly.
okay, okay, okay.
Okay.
Okay, thank you.
Thank you.
So, so the I hope this previous talks and all the things might have gone well. I could not attend all those things, but I'll try my best to make this presentation more fruitful, and I hope you will enjoy that discussions. Anyway, this session is actually a after lunch section, right? So it will be something like we call it a sleeping time. So I hope you all are attentive to this presentation, and also I request all of you, if you are having any confusion, any sort of doubts and all the things, just please let me know. Uh, just one second. Shall I switch off my video so that if any participant is having any kind of internet trouble, so that will be resolved? So I'm switching off my video. Right. So we'll be here for 2 hours, and the first, I think my voice is clearly audible to all of you.
Yeah, clearly audible, sir.
Okay. So
Yeah.
within these 2 hours, we'll have something like this, but we may not go like that, and we can have our own way of managing the time, right? This is what I believe.
Sir, please maximize the screen, sir.
Okay, okay.
Okay. Thank you.
So
Yes,
this is
please.
what my belief is. My belief in the sense, I believe in this way. So you may think this is a selfishness or something like that, but this is what I believe. Before doing something, I need to know what I am doing and what for I am doing, right? You all do like that. So whenever you are doing, there must be some motivation behind that. What for you are doing, why you are doing, and all this, what, why, in all this. So if you are not happy with that one, at the end of the day, you will not feel something different. You'll be thinking that whatever I did today, was it worth to do or something like that. Okay. So this is what my feeling is, and you may ignore these things also if you don't like that. Anyway, this outline of this talk will be like this. It's a broad outline, so let us not stick to that one, but it's just to fulfill this process. It is something like some neural network discussions. Then we'll go to the deep network, and we'll discuss about the two variations of the deep network, that is autoencoder and CNN. That we'll talk about, and its application to pattern classifications. How classification task is being done using these two networks. Okay. So these are the pre-assumptions I need to take, because 2 hours is not sufficient to discuss about these two things. So what I presume that the following aspects are known to all of you. For examples, what is pattern recognition, what is feature, what is levels. In a basics level, I mean, basic level in the sense you should have a feel of those things. In a scratch level, I'm just talking. What is supervised, what is unsupervised, what is training, testing, selections, extractions, what is features, what is overfitting, generalizations, what is data, what is big data, and so on. Anything related to the basics of pattern recognition. So I just want to know from all of you, shall I assume all the things are known to you? Please, participants, please let me know. Shall I assume that all the things are known to you? Dr. Bimal, can you just ask the participants whether they are all aware of all this, or should I go through that? Hello? 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 Am I audible? Please respond, anyone. Okay. Okay. So regarding this queries, should I presume that these are all known to you? Please respond. Okay. Okay. So it's good that they are all known to you. So don't get confused with this terminology, because most of the time I'll be using this terminologies very often. Okay, fine. So I'll just skip this person. So first of all, what do we mean by intelligence? Okay. So let it be some kind of interactive and all of the things. Do you want to interact with in this discussion, or just you'll be a silent listener only? And Dr. Bimal, can I? Are you there? I don't know what is happening. Hello.
Yes, Meher sir.
Yeah. What I'm asking is that can I have the interactive session like here?
Yeah. Chat
Or
box
just,
they will post, sir.
or
No.
just participants wants to have only a silent listener.
Yes, yes, yes. Sir, they can use the chat box and they can interact their queries, sir.
But when I'm showing that slides, that chat box is not visible to me. I don't know why.
One second, I will check it.
See, when I'm sharing the slides, the chat
Yes,
box
yes.
is not visible to me.
Yeah, this screen only visible to you. So
Yeah, only the screen is visible to me.
yeah. This will be visible to you.
So if there is any disturbances or any response from the other side, I may not be in a position to know that.
No
Correct?
issue, sir. I will ping you. Once completion, we can check with the queries and we can discuss.
Okay, okay.
Okay, sir.
So before going to that things, let us try to understand what we mean by this intelligence factor here, because this deep learning, machine learning, artificial intelligence, all the things are the basis of all these things is the intelligence factor. How do we define this intelligence? How do we realize this intelligence? How do we compute this intelligence? That is the main factor here, and that is the thing which we should understand, and we should have a feel of that one. Then only we can enjoy this kind of discussion and further uh, research activities. Okay, so the intelligence, what I am telling here is nothing but in terms of decision taking abilities. The moment you are taking a decision, then the next moment you think whether my decision is correct or incorrect. Even if it is correct, to what extent it is correct. So that is where the intelligence comes to the pictures. The more accurate you are in your decision, the more intelligent you will be. That is what the a kind of general statement about the intelligence. Okay. Now the thing is that this intelligence comes from where? How do we become an intelligent person? Actually, it's a cognitive problem. Okay, and the more and more we learn, the more and more we have that experiences, the more and more better decision we can take, and at the same time I can say I'm the intelligent one. So that is why one definition you can say intelligence is what you do when you do not know what to do. If you know something and if I'm asking and you are answering, that is not the intelligent thing. So when that intelligence factor will come to the picture, when you don't know something and I'm asking and you are giving some kind of approximated answer to that questions, then your intelligence factor comes to the pictures, and that you are the intelligence is all about. We normally call in deep learning or machine learning is called the ability of generalizations. Okay. So anyway, it's an hypothetical idea which we have defined as being reflected by certain type of behavior. Okay. So basically, intelligence we talk about in deep learning and machine learning is some kind of abstractions, some kind of summarizations, some kind of estimations. The more the abstractions ability we have, we call them as intelligent one. Abstraction means, I believe you are understanding. Abstractions is something like squeezing the informations and convey that. And but while conveying that squeezed informations, keep in your mind that no information should be lost. Information amount, information rate, everything should be intact. Only thing is that that information will be conveyed in an abstract manner, in a compact manner. Now we human being has that abilities, and that's why we are called as intelligent one. We have that ability of abstracting. We have that ability of uh, estimating. Okay, and where from this comes these abilities? It comes with the adaptations, changing behavior. So the moment you learn the things, the moment you change your behavior, the change your parameter of your system which you are learning, that is called the meaning of adaptations. So the better the adaptation of your system, of your parameter of the systems which you are using to take any decision, the better abstraction you can do. And the moment you can say, I have done some better abstraction, then I can call myself as the intelligent one. Okay. So intelligence comes from the following: learning, and or you can say some kind of adaptation process. If you are not adapting to the situations, then you are not able to take a better decisions. That means you cannot be called like an intelligent one. So intelligence comes from learning or adaptations. So you need to adapt and change yourself according to the requirement. And if you become fixed and you become adamant, then it becomes very difficult to take a decision out of these situations. Okay. So what is computing? Computing is something like we use mathematical operations. So that is what the meaning of computing. Now, if that is the computing, then what is intelligent computing? Intelligent computing is something like that. The kind of intelligence factor we human beings are having, that we want to compute. Intelligence is being computed. So whatever we are doing, we are expecting some machines who will compute the intelligence in such a way that who can take a better decision, who can take a decision similar to a human being. And that computing of intelligence we incorporate in the machine, and that machine becomes your model. Okay. So why we require data? Because data gives us the informations, and the data can be understood by the systems, whether it is machine learning system or deep learning system or any kind of model. So that's how we require the data. Okay, very quickly I'm going. So intelligent computing with data, that is what the requirement. Fine. So then if the data are available, why not traditional analysis we can go for, and why we require the machine learning high computing abilities should be there? Why should we go for a learning which should be deep in nature and all the things? Because there are several problems with the data sets, something like tremendous amounts of data, high dimensionality of the data, high complexity of the data, and many more things. Then once obvious questions will come into the picture, why not human data analysis? Why human beings are not taking part in doing the analysis job? Why do why we are dependent on the machines who is taking a decision for us? Because these are the basic problems. Human experts are prone to bias and errors, and that is the main reason why we cannot rely on human being. We have some kind of emotion and sentiments which is stopping us to take a better decision at proper point of time, and it is extremely time consuming and costly, because buying an expert is more costly than buying a machine. Okay. So most of the time, human decisions are made not on the information's rich data stored in the database, but rather on a decision maker's intuitions. And that is how the machine learning works. So this is your model input and output. I'm just keeping these things. You all know that. So when this machine learning or deep learning or AI are not required at all, this is when you don't require any kind of systems which changes itself. And what is that? When the relationship between all input and output variable is completely understood. You got my point? So actually this is your model. Actually whatever model you think of, whether it's a machine learning model or deep learning model or any kind of decision taking model, so it has some input variable and it has some output variable, and it has some system parameter. So the purpose of the system parameter is nothing but mapping of input to output. When this mapping is known to you, you don't require any kind of learning. You don't require any kind of systems which changes itself. But actually, we don't have that kind of things in real-time system. And that is why we require systems which changes itself. Okay. So now coming to this, our actual fact. That was something like some kind of introduction things. So you all know what is a pattern is, right? Because we are talking about pattern recognition, pattern classification, all the things. So I have presumed that you all know that one. The moment you say that you know the pattern, I believe you also know what is a feature. And now we are going to understand what for we are going deep learning. What is the motivation behind that deep learning? Let me first talk about the motivation. Then we'll talk about the modeling part of deep learning models. Okay. Now, what is a feature actually? So definition wise, a feature should have following characteristics. Correct? The characteristic properties or functionality expression of an object is called feature, that you all know, right? Generally, optimum indexes to be a feature and a set of features, because these are the two parameters which we need to satisfy. Next, representation of a particular type of pattern. A feature should have that ability. It should have the ability to represent a particular type of pattern. Particular type means particular class levels, particular pattern class. It should be as compact as possible. Why do we record these things? Because we need to have efficient storing abilities. Because more the number, more storing capacities we require, and we don't have that one. We don't want to use more storing space for. Okay. So this is the problem with the Google Meet. I'm unable to know what is happening there. Okay. The third thing is computationally simple, because I don't want to make more computation to take a decision. So my feature should be computationally simple. It should not take more computation. The other one is perceptual relevant. If trying to implement a human inspired classifier, it should be relevant in nature, because there are several informations are available which are not relevant to the decision making process. So it should be relevant in nature. So it should pave the way to a good discrimination of different classes of objects, right? These are the characteristics of a feature that we all know. Just to for the refreshing your memories, I just went through that. Now once you know the pattern and features, I believe you know this pattern recognition systems. Here your input goes and here your output comes out. In the first step of operations, what do? We characterize the input. In the second step, we pre-process that out characterization or information, and that characterized or processed information goes to the model development. In this information pre-processing, we have different steps of operations. One of them is the feature selection, extractions, normalization, standardizations, and all these things. So our today's discussion is here, feature selection and extraction. I hope my mouse movement is visible to all of you, correct? I hope my mouse movement is visible to all of you.
Yeah, it is visible, sir. Visible.
Okay. So today our discussion point is here only in the whole processing things. I believe you understand the pattern recognition system here. Okay. Here the input, here the output, and this is what the processing steps. And within the processing steps, we are here where we are going to discuss. And this actually the motivation of deep learning. Feature selection and extractions. That is what we are going to discuss first. Then we'll develop the model. Okay. So a feature, for example, a single object can be represented by several features that we all know. So a feature can be of this kind: shape, size, color, some other things. And if I want to define them in terms of mathematical notations, it looks like this. So X is a vector, it's a pattern which has d number of features. So I can say X is a point in d-dimensional feature space, correct? Now, if I'm having some number of data points like this, just try to understand. See this triangle, circle, and these things are the data sets. Okay. Now, given this data set, if somebody asks me, you group them into classes. Okay. You group them into classes or categories. Because there are several ways to do that. If somebody wants, that grouping can happen through in terms of shape. Then that grouping can happen in terms of size. That grouping can happen in terms of color also. And you can see these different categorizations of different classes, but the data set is same. So what decision you are going to take on the data set, that you should know first before going for any kind of modeling. So unless and until you have that intuition, you have that kind of idea what you are going to search out, what you are going to take the decision, then you will be lost somewhere. So first of all, the first step of development of any decision making model is that first try to understand what you want from the task. So for example, here there are three different kind of decisions you can have. So which one you want? Because why I'm emphasizing on this particular factor is that which one you want, that only tells you what kind of features you have to take. Because these feature informations only help you to take a decision whatever you want. If you change your decisions, that means you have to change your different kind of feature. With the same feature, similar decisions taking is difficult. So first of all, you need to understand what is your task. Second thing, you need to understand the relevant informations related to that particular task. Then only you can end up with a proper decisions. Correct? So we have different names of the features. Sometimes we call the features as dimensions, attributes, variables, and so many things. Okay. So now comes to the pictures of representation and convenient visualizations of the features informations. These are all the motivations I am talking about. Then I will go for the model development. So the next factor is representation and convenient visualizations. The meaning here is that I believe you are all understanding what we mean by feature and what we mean by dimensions of the informations. The number of feature talks about the number of dimensions of the informations. More the dimension, more the feature, more the information with us. Correct? But the thing is that which information is more informative for me, that I need to understand. It is something to say that, let us say I am taking a photograph with my camera. Try to understand the example. Let us say I am taking a photograph with my camera. Now tell me, how many dimensions that camera can capture? How many dimensions that camera can capture? Please interact with me so that it will be more interactive. Otherwise, I will also feel bored and you will also feel bored. Are you understanding my point? When you are taking a photograph using your camera, how many dimensions your camera can capture? That means in how many feature space your camera can reveal the information. Can anyone tell? I don't know whether you are following me or not.
Yes, sir. Yes, sir. Everybody is following. No issue, sir.
You have to interact with me so that I can understand you. Okay. So somebody is writing multi-dimension. Multi means what? One or two or three or four or five. Someone is writing 2 dimensions. But how many dimensions we can see with our eyes? No, how many dimensions we can see with our eyes? These 2 dimensions a camera can capture, right? So how many dimensions we can see with our eyes? So what I'm trying to say is that we can see many dimensions with our eyes. So try to visualize the situation when you are taking a photograph of a particular scene. See, when you are asked to take a photograph, do you just take the photograph without preparing yourself? Preparing in the sense, you just try to go this side, that side, up, down, like this. You try to adjust where your camera can capture most of the information about the scenery. Correct? So that means the number of dimensions available in this information space, you want to capture the most informative informations out of these things. So you want to reduce the number of dimensions, that n dimension, to 2 dimensions, which is not so easy one, but we conveniently do that one. These aspects of this ability we are going to incorporate in a machine. Okay, try to understand these things. Next, happiness with feature. That means whatever feature informations I have, am I really happy with that? Happy in the sense, is it informative in nature? Is it going to help me in any way? When I'm telling a feature has no information, what does it mean? When I'm telling that a feature has no information, what does it mean? I mean not in terms of the features information contained. What do I mean? I mean the decision dependency of that feature information. It is something say like an information is useful for me may not be useful for you. It may happen, right? So for my task, which information is useful, that I should know. That is what the meaning of quality of informations. That information should be decision dependency. It should have that ability to take a better decision. Not that what amount of information that feature contain. Okay, so these are the three index through which we measure the feature relevance. One is the number, another one is the quality, and third one is the set of numbers. Number means, because we all know not all informations are informative in nature. This is a natural phenomena and we exploit it. That means whatever information is available in front of us, not all of them contain equal amount of information. Someone contain more, someone contain less. So because of that uneven distributions of information in this feature, we get the advantage. And what do? We take the best information contained features and use for our purposes. So for that reason, we need to know how many are to select. Let us say I'm having 10 features. Out of the 10 features, how many I should take? I should select 2 features or 6 features or 8 features, or I'll take the whole set of features. Because at the moment I'm taking the whole set of features, that I am committing more computation, which I don't want to do. So selection is must here. That is what the just now I was showing, right? Feature selection is must in the decision making process. Now the task is how to do the feature selection. Second thing, or second index or happiness of the features, quality. As I just now told, it is highly subjective in nature. The quality of information varies from person to person. Information in a feature is good for me, bad for you. So it should be decision dependency, not individual informations. And the third index is set of informations. So which set of informations I should take? It is something like that. Let us say I have 10 numbers, 1, 2, 3, 4, 5, 6, 10. And if I am asked to select any 5 numbers, which 5 numbers I should select? Or in the other way around, in other example, let us say there is one hotel is available, and in that hotel one scheme is going on. You pay the fixed amount of price, and there are 10 number of dishes. And the moment a customer is going to that hotel, that customer is asked, you select any 5 items out of the 10 items, but you have to pay this fixed amount. Now the question is, you have to select 5 dishes out of the 10 dishes. So which 5 dishes you will select? So that you need to decide, because there are several such combination of 5 dishes. So which one to select? Because it is mathematically proved. There is a mathematical proof behind all the things, which says individually a feature contain good amount of information. But the moment they combine with one more feature, that combined information deteriorates. Try to understand the scenario. I am having, let me just open one, this one. This my pen brush is visible to you? My pen brush screen is visible to you?
Sir, visible.
Okay, okay. Let us say I'm having 4 features: F1, F2, F3, F4. Okay, I have 4 features, and I am asked to select any 2 of them. Okay, try to understand the questions. I am asked to select any 2 features out of the 4 features. Okay, before taking or before selecting any two features out of these 4, I am given another information. It is something like this: the amount of information present in F1 is greater than F2, is greater than F3, is greater than F4. It can happen like this also, right? F1 contains the most amount of information. The next maximum information contained is F2. The next one is F3, and next one is F4. Let us say I am asked to select any 2 features out of these 4. Which 2 I will select? Can anyone tell me? Which 2 features I will go for? Anyone? You got the question? You have 4 features, and these are the ranking of information contained in these 4 features. And you are asked to select any 2 features. Which 2 features you will select? Anybody? F1 and F2. Anybody else? Anybody else? Out of the 4 features, which 2 features you will select? Someone told F1 and F2. Anybody else? I don't know participants are following me or not. Okay. Okay, the question was which 2 features you should select. Someone told F1 and F2. I believe this answer came just because it is given something like this: F1 contains the most amount of information, F2 contains the next most amount, then F3, then F4. Actually, the answer is wrong. It is not necessary that if you combine F1 and F2 and take these 2 feature set, it will perform the better way. That means you can take a better decision. It's not always necessary. It may so happen that F1 and F4 perform better than F1 and F2. Okay, so this is another problem of feature selections. Which feature you have to select and which set of features you have to select, that you need to decide, and which is a very difficult task, right? So these are the parameters, you can say, or these are the indexes, you can say, which help us to go for a particular feature or particular set of features, right? Now, okay, so now the thing is, the role of features that we'll discuss. Okay, now the question is, whatever you selected the features out of this set, are we really happy with the available features, or are we actually happy with the selected features? Let us ask ourselves. Okay, and the task here is something like feature selection. We are going to select the features, correct? Which features we need to take and which set of feature we need to take. Keeping in mind of these 2 tasks, we select the features. So I don't need to tell what for you are selecting the features. You are understanding that. Okay. Next. Let us say whatever selection you made, are you really happy with that selection? If not, then what next? If you are not happy with that selection, then what for you did the selection? And what you will do after that if you are not happy with that? Then the possible answers will be, if not selection, then extract it. Because the difference between the selection and extraction is very clear. Selection is nothing but you are picking some number of features out of the available features. That means you are not touching the feature value. You are just picking them. So the selected feature set is a subset of original set, feature set. Okay. Whereas the extraction has a different way of dealing with the features. Extraction actually manipulate or changes the value of the feature. Somebody may go for both extraction and selection. So in other words, what I am trying to say is that when option is not given, create it. That means extract it. And that is what the meaning of feature extraction, and this is the motivation of deep learning network. Please think, is it so easy to select and extract the feature? Because in a conventional way, whenever we select the feature and extraction, we use certain prefixed or predetermined mathematical operation, whether you go for selection or extraction. When those things are prefixed, that means it is already defined to you. When you are selecting the informations or when you are extracting that information, accordingly you will get the information. You will not get any kind of creativity. You will not get some kind of extra information out of the available one. Whatever it is there, just predefined way or predefined manner, you are going to get that one, whether through the feature selection or extraction. And that is what we call normally is that handcrafted features or engineered features. These features are handcrafted. That means we have designed that informations how to extract through the available features or from the available features. Okay. So again, the extractions can be specific and generalized. Whether we are extracting or selecting from a restricted space or unrestricted space, that we need to see. So we need to take the help of mathematical power or in a intuitive manner, or with a intuitive power you are going to select or extract. So if you are given an option of these two things, one is the mathematical power and another one is intuitive power, which one you will prefer? Obviously we human being will prefer for intuitive power, because mathematical power or mathematical way of extracting the information or selecting the fixed information is fixed in nature. There is no dynamism in that feature information or feature extraction information. Whereas in the intuitive power, you can have your own intuition and you can have your own way of selection of the features. So I think we all should go for the second option. That is what the intuitive power. Reason is simple, because it is not problem specific. Not only problem specific, it is not data specific. Irrespective of the data, irrespective of the things, we can go for this kind of intuitive power. And for that, we require deep learning network. And that is where the birth of deep learning starts. Okay. So feature extractions, there are several ways of feature extractions. We normally call it handcrafted features or engineered features. I believe you are all aware of this kind of features: shift features, spin images, ripped, tecton, HOG, different kind of features. These features are called handcrafted features or engineered features, okay, which we have designed. But most of the time, these features do not go along with our decision, because these are all handcrafted features. Let us say some problem comes to you which is innovative in nature, which is different from our handcrafted way of information extraction. Then these kind of features will never work to take a better decision. At that time, you need to take the help of intuitive power. through which you automatically represent the information in such a way that your decisions will be favorable. That is why the feature extraction happen in deep learning is called representative features. We represent the features according to our own convenience. Correct? So there are two ways of feature extractions. Normally, what we do here, we perform the feature extraction serially or parallelly. The first one is called linear combination of information feature extraction. That means each of the box is a non-linear function. This box represents a non-linear function. So we give the input through this non-linear function, and this non-linear function extracts some amount of information from the input data, and that it will be combined here, and that will be useful for your decision making process. Whereas in the second way of information extraction, here all these nonlinear functions are cascaded. They are working not parallelly, they are working serially, one after another, like this function. Mathematically you can see this looks like this, whereas this linear combination looks like this. Now which one is more preferable out of these two ways of feature extraction? One is called shallow network and another one is called deep network, and that is what the name deep comes into the picture here. In the shallow network, we go for linear combination of feature extraction, whereas in the deep network, we go for the cascaded form of the information extractions. So which one is more complex? Obviously, the deep way of information extraction is more complex rather than this shallow way. Okay, so that is why the term comes into the picture. Whenever we call shallow network, means which is not deep. Our processings are like parallelly. Whenever we say it's a deep network, means our processings are not parallelly in a serially manner we perform. Okay. In other way, we can visualize these operations like this. These boxes are some, just now I was telling, no, the boxes represent some nonlinear function. Let us take some nonlinear functions like this, sin x, cos x, and all this. If they work together parallelly, then this is called linear combination of information extractions. Okay, and that is where we call it a shallow network. The moment they work like this, then we call it a deep network. So each sample or each simple function will have parameters subject to the learning. Okay, learning will be different task, but the functions whatever you are using, are they working parallelly or serially? That makes the network deep or shallow. Okay. Now, the birth of deep learning started from neural network only, because most of the concept of deep learning is similar to neural network processing steps. Okay, so I believe you all know neural network. So another question comes to you: should I assume that you know neural network? Because to understand the deep learning network, we need to understand neural network. So are you all sure about the neural network concept? Please tell yes or no. At least in the text format you can see. Shall I assume that you all know neural network? Okay, fine. Okay, let us not go to the details of the neural network. Let us try to understand how neural network performs. Okay, and what is happening in neural network and what are the problems with the neural network, so that we go for deep network or deep neural network. Right? So in the neural network, what is happening? This is what in conventional neural network. And what is happening here? Let me go to the directly to the processing steps. Okay, this is what neural network is. So issues with the neural network. So what a neural network does actually, it creates a decision boundary, non-linear decision boundary in a random way. From the beginning, you create the decision boundary randomly. Okay. Now, the moment this decision boundary is random in nature, this randomness of the decision boundary comes from the randomness of your weight factor. Whatever weight you are taking, that actually decides your decision boundary. Now, let us say there is a task here. Okay, there are some red ball and there are some yellow ball, and you are going to draw a decision boundary to partition these two group of balls, and you are using a neural network. And in that neural network, what you are doing, you are taking a shallow neural network. That means a simple one hidden layer, one input layer, and one output layer. So when you start processing your neural network, what do? You take the random weights, and that random weights creates a nonlinear boundary like this. Okay, which is not correct. So what do you do then? You start tuning that weight parameter. The moment you start tuning the weight parameter, your decision boundary keeps on changing. During the training, you adjust the weight parameter, correct? So this way, your training parameter changes your weight parameter, and your decision boundary comes to this point. And eventually you get this kind of decision boundary, which actually you want, right? So to get this decision boundary, you had to train the weight parameter. And that is what your neural network does, correct? Now, what is the problem here? Anyway, we got our solution using the neural network. What is the problem here? The point here is weight learning algorithm for neural networks are dumb and unreasonable. Do you agree with me? They work by making thousands and thousands of teeny adjustments, and each time a network has to do better and better and better. But perhaps a little worse on many others. It is something like this. By dumb luck, eventually this tends to be good enough to learn effective classifier for many real-time applications. We play with the random balls. We don't know where we are going to land. So it's something like that. By dumb luck, we get this solution. But this may not work in many times. So some other points. If that activation function is a nonlinear one, then one hidden layer of a neural network, in theory, can perfectly classify any kind of problem, any kind of level of difficult problem. So that means a set of weight exists for any kind of problem. What do we mean by a set of weight exists? That means a decision boundary exists. That means you can draw the decision boundary between the class levels. You can draw the decision boundary between the class level for any kind of class problem. Okay, but only problem here is that how to get that decision boundary through the neural network. The problem is finding them. Okay. So some other way, something like the by the way points. If fx is a linear nonlinear, then neural network can draw straight lines, and this is what happens. Okay. So I can have a linear boundary separator between these two groups of samples, and that is what the birth of your SVM is all about. Okay, let us not go to that particular aspects, right? So the main task here is features and representation, and the task here is fitting a curve accordingly. So may think of representative feature instead of handcrafted and engineered features. That means the whole task of decision boundary designing process depends on the type of features you are going to take, whether it's a handcrafted or engineered or anything else which is predetermined. So most of the time it will not work for a different innovative kind of problem or innovative kind of task. So what do? We go for some kind of representative features. That means the network should be in a position to represent that information into a features which is more suitable for our decision. That's why we call it representative features. For example, recognizing a face. For example, recognizing a face. Let us say you are recognizing a person. Now, your way of recognizing a person, is it same thing as my way of recognizing a person? Or your friend's way of recognizing a person? Answer is no. Different people recognize the face of a person in a different manner. Somebody recognize the face through eyes, nose, teeth, their positions, and several other parameters. Now, in general, which one is the most appropriate parameter to recognize a face? It is very difficult to say. So it all depends on how you are representing that information in terms of features. Okay. So that actually gives you the motivation for deep learning architectures. Okay. So I should have a feature of my choice which has to be evolved automatically and which will act as a representative of my task. May not like helpful for me your features, as my model is different from you. That means whatever representative features I collected may not be good for you because your model is different from my model, although our task is same. Okay. So these are the motivations of deep learning architecture. I hope you have realized the motivation of deep learning architecture. What for we are going for deep learning? What will happen if we don't go for deep learning? Shallow network will not fulfill our desire. Shallow network will not perform better, or it will not create a good model, or it will not generate a good model. So that is the real-time problems we normally face, and that's why we go for deep learning architectures, where the expression or informations are in the representative format. Information evolves itself. The representations abilities of the features evolves. You don't need to control that evolution process. Whereas in the engineered features extraction or handcrafted feature extraction, that evolution doesn't happen. Whatever predefined task is there, it will perform that. Okay. So we'll discuss here two different kind of deep learning network. One is the autoencoder and another one is CNN, convolutional neural network. There are several other deep learning architectures are available, but here to simplify our task, we will only discuss these two deep learning models. Okay. So first we will go for the autoencoder, because as I told you, there are different kind of deep learning models are there. So different purposes people have developed different kind of network. Okay, so let us not go to that part. So first we will discuss about the autoencoder. So what is the motivation for that autoencoder? Because the motivation of the autoencoder and motivation for CNN, although they are same in the feature extractions part, but they are different applicabilities. They have different applicabilities. Most of the time, autoencoder is seen as a compressed information format. That means your information is getting compressed or represented in fewer number of features, and those features are used for classification. Whereas the motivation of CNN is not like that. Okay, we will come to that one. Okay, when we talk about a feature detector or feature extractor, what is the purpose of that feature detector and extractor, and how it happens in your neural network? Actually, that happens in your hidden layer. So what is these units are doing? The hidden layer unit of a neural network, it actually tries to learn, it actually tries to understand which are the unique information present in your input, so that it will so that it will be helpful to take a better decision at the output level. Okay. So the hidden layer units becomes self-organized feature detectors. Some of the weight parameters becomes very high, some of the weight parameters becomes very low according to our adjustment. Okay, so these are the purpose of the hidden layer unit. Most of the cases, what happens, we all use neural network, we all use hidden layer, but we never realize what is that purpose. What are the purpose of the hidden layer units, that neurons? Okay, so let us say it is something like this, these hidden layer units, and they try to extract the unique features which are different from others. Okay, so if this is your input, so from this input, this hidden layer unit tries to extract some kind of information which are unique in nature. Because when I am telling you, tell me what is this character, you have your own way of understanding the information and telling that output, correct? So that is what the purpose of the hidden layer units. So it sends a strong signal for horizontal lines for this particular example and ignoring everywhere, correct? So this is what it does. So I'm just keeping these things. For example, here some handwritten examples are given, characters are given to your neural network. So what your neural network hidden layer does, they tries to extract the unique information. Sometimes what are the vertical informations or vertical sketch, what are the horizontal sketch, what are the diagonal sketch. So all the things, informations are extracted by your neural network, and then it provides a decision. It is same thing like the way a human being takes the decision. When I'm writing some character here, and if I'm asking to tell me what are the features or informations you are extracting to say that this character is 1 or 2 or 3 or 4, probably you may have your own way of reasoning. Okay, same way your neural network works. Fine. So some hidden neuron extract the vertical informations or vertical edges. Some neurons extract the horizontal edges. Some neurons extract these kind of circles. So just for the illustration purposes, it is mentioned. Okay. So finally, what they do is that they extract all these informations. We call it a lower level informations. And slowly, this lower level information combined together and gives you the output. Okay. So that means multiple layer makes sense. Just now I discussed about what your hidden layer unit does. Your hidden layer unit extract the information. What are those information it extract? Some neurons extract horizontal edges, some neuron extract the vertical edges, some neuron extract the diagonal. Like that, different kind of edges each of those neuron extracts. So normally we call it a low level information. Now just by knowing the low level information, can you take a decision that what kind of character it is, 2 or 3 or 4? It is not possible. You need to combine those informations, the vertical edges, your horizontal edges, the small circles, big circles, in such a way that will create some kind of character, and that is called high level information. So for each level of information extraction, we require one hidden layer. So the logic is very clear here. The more the number of hidden layer, the better the performance of your neural network. Most of the cases, what do? We take one single hidden layer. You go for 2 hidden layer, you go for 3 hidden layer. So that means the conclusion here is that multiple layers of hidden layer neurons make sense, and that is what the autoencoder does. So these are the people who actually describe the different layer of information processing, and so they realized through different medical advances, medical domain experts, that our brain works in a layer-wise manner. We don't take decision in a single layer. Some decisions is being taken in the first layer, Those information go to the second layer. Some manipulations happens there. Then that goes to third layer, fourth layer, fifth layer. After having 6, 7, or n number of layers of information processing, then only our decision comes. But we don't know how many layers of processing happens in our brain. But it happens in a multiple layer of processings. And that is why your deep learning network works. Sometimes people say, can I not take neural network of more number of hidden layer, and can I not call this as a deep neural network? So such kind of questions comes into the picture. But the problem is that the moment you increase the number of hidden layer of a neural network, several other complexity comes into the pictures. And that is why those things cannot be used for decision making process. Okay. So this is how our brain works. Okay. So let us say these are the objects. These are the objects which we need to recognize. So those things normally is in the form of pixels. So in the first level of information, edges comes. This next second level of information, the combination of the edges, and at the next level informations, we get the actual object models. Okay. So as I told you, the multiple layers of processing makes sense. Our autoencoder actually does like this. Let us see how autoencoder works. Before that, okay. So this is one problem actually is creating trouble to neural network. That is what we normally call as vanishing gradient. Okay. So you all know how, one kind of gradient descent algorithm we use to train our neural network model, right? That weight parameters. Okay. And that weight parameters, when we change, we use some gradient term, and that gradient term is becoming 0, then that particular weight cannot be changed. And that happens when we take multiple number of hidden layers. Okay, that is what we call the vanishing gradient. So normal neural network with more number of hidden layer faces the problem of vanishing gradient. Okay. So what people thought about something like a new way to train the multi-layer neural network. So what they did, they used first layer, one hidden layer, one output layer, freeze them, then go to the second layer, then go to the third layer, then go to the last layer, and finally you come out the decisions. But how it will happen? Instead of training or making the whole network trainable together, you perform the training step by step manner. In each step, you train one hidden layer, and finally you give your decision. Okay. So how it will happen, and that is what the autoencoder is all about. So here we will discuss about the autoencoder. This autoencoder, mathematically we say it is nothing but the replica of principal component analysis. I hope you all understand the principal component analysis, right? We normally use that principal component analysis for feature extraction. And the purpose of principal component has many, there are many purposes to go for principal component analysis, because most of our informations are dependent in nature, they are correlated. Okay, so to break the relationship between informations, okay, that means we want to make uncorrelated informations. From the correlated information, how to get the uncorrelated information, and that is where your PCA works. Okay, but the problem with the PCA is, okay, let me not go in details of that one. The problem of PCA is, yeah, this is what the PCA is. Okay. Okay. So let me not go to that one. PCA. Limitation of PCAs. What are the limitations of PCA? So let us try to understand what is PCA is all about. Then you can easily understand what is autoencoder, because autoencoder is a generalized version of principal component analysis. If you have understood PCA, then it can easily understand the motivations of autoencoder. Other way. So what are the limitations of PCA? PCA has very big problem here. What are the problem? It only extract linearly derived features. Are you understanding the point? Principal component analysis extract linearly derived information or linearly derived features. These are learned variables of our original feature space. Okay, so this is what the equations of the PCA is. This is your input information. You use some kind of transformation. So that transformation actually transforms your input to another domain. Okay, and from that domain, you again come back to the original domain. So this transformation normally happens in a linear manner. That means there is no loss of information. From original information to squeezed information, and again from squeezed information to getting back to original information, that happens linearly. That means there is no loss of information. Whatever information we have given here, the same information we can get it here through principal component analysis. So this is what the equation. I believe you can understand this principal component analysis or PCA equations. Okay. Now, what is the problem here? As I just now told, it can only extract linearly derived features because the transformation is a linear transformation. If you are having a nonlinear problem, if you are having a complex nonlinear problem, then your principal component analysis cannot handle that one, cannot address those things. And most of our real-time problems are nonlinear in nature. We require a transformation. We require a extraction procedures which are non-linearly in nature, which can extract non-linearly derived feature, where principal component analysis only extract linearly derived features. So the relationship between PCA and autoencoder is these two terms: linearly extracted information or non-linearly extracted information. PCA extract information which are linear in nature. The moment you convert that linear to a non-linear information extraction, that becomes your autoencoder. So principal component analysis, I can call it as a linear transformation, whereas autoencoder can be called as a non-linear transformation. In other way, I can call autoencoder as non-linear PCA. If I can use a term called non-linear PCA, that is nothing but your autoencoder. Okay, and this is how your autoencoder works. You give your input here and try to get back the same thing at the output with a minimum number of hidden layer units, which actually represents your input information in such a way that it can give you back the original information. So the first part we call it an encoder, and the second part we call it a decoder. So that is where the name autoencoder. Both encoding and decoding are happening together, and that is happening in a non-linear manner. So the whole process is nothing but it's a non-linear principal component operations. Okay. So this is what is this. If you give your input here and you are expecting the same input here at the output, and if you put a hidden layer which is having less number of units than your input and output, then this is called one level of autoencoder or one stage of autoencoder. So how we are doing that? This is what you have to do. So normally in neural network, what you do? Let us say if you are taking two layers of neural network and you together train them. No, that we are not going to do here. What we will do? Step by step, we will train. We will train the first hidden layer, then we will go for the second hidden layer. Okay. So this is what it happens in autoencoder, and that is why sometimes the extraction process in an autoencoder is called unsupervised way of information extraction. Why it is called unsupervised way of information extraction? Because here you don't have any target value. Whatever input you are giving, the same input you are expecting at the output. So this is nothing but a simple neural network having one neural layer, one input layer, and one output layer. So whatever input you are giving, the same input you are expecting at the output. So what is the benefit here? You will see it contains one hidden layer here which has lesser number of units. Let us say your output units or input units both are same because same input and same output. Okay, let us say there are 6 number of units here in the input and output, whereas here your input in the hidden layer it has 3 number of units. So what is happening here then? That means this 6 amount of information is getting represented by this 3 amount of information. So these 3 information can be called as a kind of representation of this 6 number of informations. So from these represented informations, we can get back our original information. Okay. Now what we'll do is that we will take a neural network which has one input, one output, and one hidden layer. We will train them as usual. This becomes your neural network. You train the neural network and get the output. Get the output means get the error factor 0. You minimize the error. The moment you saw that error is minimized, that means what conclusion you get? Your 3 informations, whatever you are getting in the hidden layer, is actually representing this 6 information. Now, if that is the case, why do you require this 6 information to take a decision? You can take these 3 information. Because these 3 information contain same information of all these 6 information. So these 3 informations are called representative information. Okay. Now once you are done that one, then you discard the decoder part. This is called decoder part. This is called encoder. Okay. You discard the decoder part like this. You discard these things. So whatever this hidden layer output it comes, you assume that these 3 are your input layer. So you put another neural network on top of this like this. You put another neural network on top of this. So like that, if you keep on continuing, you will see that your original 6 number of features are getting represented with minimum number of features. From that 6 to 3, 3 to 2, and 3 to 1, like that. And at the end, after 2, 3 layers, you will realize that this 6 number of features are getting represented by hardly 1 or 2 number of features. So this autoencoder fulfill 2 purposes. One purpose is it represents the amount of input information with fewer number of some features, and also it gives you a reduced amount of information. And the learning process, because we are not requiring any class level here, we call these things the unsupervised feature learning. Okay. So like that, if you start doing that, you will see that you will end up with a network which looks like this. Here, if this is your input layer, initially in the first stage of neural network, what you did, this is your input, this is your hidden, and some output. With that output is actually same as the input. You got the this one, you remove that decoder part. Again, your hidden layer becomes the input to the next hidden neural network. Like that, you 3-4 stages of operations you perform, and at the end you will see that you got some number of features which are nothing but the representation of the original input information. And that information you put in any classifier, and it will solve your purpose, or it will give you the decisions. Okay. So what is that advantage of doing all these exercises? The advantage here is that basically autoencoder performs two kind of operations together. What are those? One operation is information extraction, Another operation is model development. So the information extraction and model development together is called autoencoder way of taking decisions. Okay, so this is all about the, I mean, in a very brief way I discussed, this is all about the design or development of the autoencoder. Then we will go to the convolutional neural network. Okay, this is another deep learning model which is more popularly used in today's generation decision making process. Okay, so let us try to understand what is the motivation of CNN and how it is different from your autoencoder. So the motivation of CNN, although is similar to your autoencoder, but it has different purposes. But it has certain different purposes. Now let us try to understand what are the purposes. The full form of CNN, that means convolutional neural network. So the first term normally we use convolutional neural network. I believe you all understand the convolution operation. You know what is the meaning of convolution operation? Convolution operations that normally we come across when we deal with signal system and image processing things. Okay, so convolution operations, if we quickly want to just go to that one, it looks like this way. There are two kind of informations which is getting convolved. Okay, so one operation is working on the second operation and you are getting back the third output. So there are two functions, let us say x and h, which will produce you the function y. And this operation between x and h is called convolution operation. Okay, so there are 4 steps of operations that happens in convolution. That is what is that first step is that you reverse that signal process, then shift them, then one-to-one operations, and then additions. That is what the operation steps of convolution operation. Fold them, displace them, multiplication, and iteration. These are all very basic things what you can get in any kind of signal processing books. So a convolution operation happens between two functions. Okay, so one function works on the other functions. So that is why you get the convolution output, which is very much similar to, there is another operation called correlation operation. Okay, so the convolution and correlation operation, they both have lot of similarities. If you discard the first step, folding, if you are not doing, the rest 3 operations you are doing, then it is called correlation operation. Okay, so interpretation is something like this. Correlation is a measure of similarity between the two signals. You find out the correlation between the two signal or sequences, and that actually measures the similarity. Whereas convolution is the measure of effect of one signal with other signals. Here signal means function. Here signal means function. That means there are 2 functions existing. You want to measure the similarity between these 2 functions, then you go for correlation. In another way, if you want to measure the effect of one function on other, then you go for convolution operation. Now what for we are doing all these things? These are all we are doing just to decompose the informations, because the moment 2 informations are getting operated and they give a third operation, that third operation is nothing but a decomposed information, and that is what we require. Okay, so this decomposition of convolution operation can happen in 1 dimension and also can happen in 2 dimensions. That means both the signal and image. Okay, so once you are aware of that convolution operation, then it will be easier for you to understand how convolution neural network works. Okay, so let us try to understand one more motivation of this CNN apart from this feature extraction. Okay, when we take, let us say I'm having an image, okay, and that image contains an object, and I want to recognize that object. This is one task. Or otherwise, let me try to recognize the whole image instead of that object within that image. Okay, so what normally we do When an image we have, let us say one image of size 50 cross 50, and if we are using a neural network, so what is happening? So what we do, we flatten that number of pixels, and that pixel becomes 2500 number of pixels, and each of them pixel becomes one of the features, and hence we will have 2500 number of nodes at the input layer of a neural network. I believe you all have processed images through neural network. This is what you do, right? Let us say if you are taking a color image which contains 3 bands of information, that means your number of input layer node of a neural network becomes 7500. If you take a large image of 512 into 512, which contains 3 bands of informations, then this many number of nodes you have to take in a neural network. Are you understanding what is the complexity of that neural network when you are having this much number of nodes at the input layer? And that is what the big problem in neural network. And that is one of the motivation of convolutional neural network. So altogether, it becomes practically infeasible for implementation with a neural network. So one of the option is your convolution operation. Okay, and using that convolution operation, your convolutional neural network works. Fine. So this is how your convolutional neural network looks like. The way I told your autoencoder has 2 steps of operation. One is called feature extraction or representative feature information extraction. Another part is called classification. Same way your CNN also works. It has 2 parts. One part is called feature learning or feature extraction. Another part is classification. You extract the representative features through these operations, and once that representative features are extracted, then you put them to a classifier. That classifier will perform better than your original feature-based classification. Okay. So let us try to understand in a brief way what are these convolution operations, ReLU operation, pooling operation in a convolutional neural network. So these are the operations which helps us to extract the features, to extract the representative features from the input data. Once that feature is extracted, then you just go for any kind of classification and your classification will perform the task. Okay. Now let us try to understand one by one. So there are certain thumb rule kind of thing you need to take care, because randomly you cannot just take number of convolution operation, number of filters, number of bands and all the things. You need to have, you need to maintain certain decorum here. Okay. So if you are taking an image which is an RGB image, okay, and which has length, breadth and depth equal to 3, means you are having an RGB image. Length and breadth means it has number of rows and number of columns, and D is the number of depth. Okay. So normally your RGB image is having this kind of informations. So when we are going for the convolution operation for the CNN, it requires a filter, because as I already told you, convolution operation requires 2 functions or 2 type of signal or 2 type of informations. That information can be a function, that information can be a something else, but you require 2 functions to perform the convolution operation. So your RGB input image is one function. What about the other function? So other function here we take as filter. I believe those who are aware of the fact of signal processing, digital signal processing, signal and system, and when you perform the convolution operation, that convolution operation is performed between signal and system, signal and filter. Okay. Exactly same way we also perform your convolution operation. In this convolution operation, our input or one of the function is our input signal, another function is our filter. Okay, that filter actually helps us to get the inherent or the hidden information present in that image, and those informations are called representative informations. Okay. So let us take an image of LBD, length, breadth, and depth. Depth is 3, let us say. Like a convolution operation, it requires a filter, as I told, of small spatial size, length, and breadth. Okay. The same way, those who are aware of that fact, signal processing, your signal may be of in large length, but your filter size is very small. Exactly the same thing also we do here. Your signal may be or image may be of large size, but your filter size will be small one. It can be a 3 by 3 patch or 5 by 5 patch. Okay, but the depth of a filter will be same as the depth of the information here, and that is the advantage of convolutional neural network. So irrespective of your number of bands of your input image contains, accordingly you have to select the filter here. So filter depth should be same as the depth of the input informations. Okay. Now, if you have these two informations, then you go for the this convolution operations. That is what the convolution operation is all about. Okay. So let us say you are having an input image of 6x6 and you are having a 3x3 filter, and you perform this filter on these images. How do you perform? You perform like this. 1 minute. Because there are several things which I'm skipping here. 1 minute. Okay. That is there here. Yeah, the convolution operation happens in between an image and a filter like this. Let us say this is your input image and this is your filter. Your input image contains how many number of pixels here? 3 rows, 4 columns. That means 3 cross 4 image, and your filter contains 2 by 2 kernel or filter. Okay, so this filter will act on the first patch here. You will get the output. Then it will be shifted to 1 pixel. Then it will come in the next patch. You will get output. Like that, it will go in a row manner and then in a column manner. And this becomes the output of this convolution operation. This is your input image and this is your filter. Okay. So this is how this operation happens. Right. And once you are done that one, then you will get this kind of informations. Let us say I'm having an input image like this, and I have taken a 3 by 3 3 by 3 patch or 5 by 5 patch, and I perform that operation between that filter and the image like this, and then output of the convolution operation looks like this. Just try to imagine what are this information we are extracting from the input images. These are nothing but the edges. These edges actually helps us or help the model to understand what is this image content, and accordingly it can take a decision on this particular image. Now if we change the filter parameter, then we will get different types of edges present in this image. Okay, so we keep on changing the filter parameter and you keep on understanding the different kind of edges present in that input image, and at the end we combine all the edge information and we take the decision, and that is what the purpose of the convolutional neural network. Some of the operations like this, see, these are the input image and these are these filter operations. This filter is, see, this is nothing but some kind of synergy they are maintaining, some kind of order they are maintaining here. Okay, based on this information present in the filter, your image is same, but the filter, that window, okay, you just check, the values are keep on changing. The moment you are changing the filter parameters here according to your convenience, you will get different kind of information about this image. So while taking a decision, you cannot take the decision of this image just by taking only one information. If you have all these 4 information, all directional informations, then if you combine them, you will get back the original one. And that is why the convolution neural network helps the model to take a better decision. Okay. Now, the question is, when your image size is different, what size of filter you should take and what should be the output of that one? Because here you see, your image size is 6 cross 6, your filter size is 3 cross 3, and you will get an output of 4 cross 4. That means our image 6 cross 6 has been converted to 4 cross 4 here. Now, how to make a balance between them? We need the output in the format of 6 cross 6 so that model can understand that one. So size should be maintained properly. So that means we need to change our two strategies here. One strategy is called padding and another strategy is called striding. Padding means around the image, original image, we are appending zeros. Why we are appending zeros? Just to maintain the input image size and output image size. This is called padding. And stride means how many overlapping patches we are taking. 1 pixel overlapping or 2 pixel overlapping or 3 pixel overlapping. When you are taking 1 pixel overlapping, then it is called stride 1. When you take 2 pixel overlapping, it is called stride 2. Okay, so like that. So for example, here, that stride examples I'll show you. See, this is called spatial arrangement. See, these are the pre-processing you need to do. Okay, so original image is 25 cross 25 cross 3. That means the image size is 25 into 25 and it has 3 number of bands. Now what you do, you append 0 here on top of that around the images. If you are appending 110 around it, then it is called 0 padding order 1. Here it is called 220 you are appending, 0 padding order 2. These are all the things what you are doing just to maintain the image size, input image size and output image size of same. Okay. Now, if this is called 0 padding, and what is called stride? This is called stride. Whether that shifting of the patches is happening 1 pixel overlapping or 2 pixel overlapping or none. Okay, so this is called stride 1 and this is called stride 2. Here there is no overlapping here. Completely different patches we are considering here. So our number of outputs will be reduced. So if we take 1 pixel overlapping, then this is our output number. See, your original size was 4 cross 4 and you are getting 3 cross 3. Whereas with stride 2, your 6 cross 6 became 2 cross 2. So it all depends on what kind of output or what size of output you require. So you have to decide what should be the size of your stride and what should be the size of your zero padding. So once you have done these things, then you perform the convolution operations. Okay. So in that convolution operations, yeah, then you perform the convolution operations and get your convert output. Okay. Now this convolution operation and getting the convert output, we can visualize through a neural perspective because all the things are coming under the neural perspective. Okay. Okay, this is how your operations happens. Let us say you are having 3 bands of image R, G, B, and your filter size will be 3 cross 3, but number of bands will be same, which is same as number of depth of your images, right? So this is called input and this is called filter. So if image size is 6 cross 3, 3 is the depth, and filter size is also 3 cross 3, and its depth is 3. This depth you cannot change. It should be same as the depth of the image, but here only you have the control. You can make it 3 cross 3, 5 cross 5, 7 cross 7, whatever you want, you can do that one. Okay, and accordingly you get your output. So this is what normally we call it. I mean, see, This operation, again, the convolution operation can be of one-dimensional, can be of two-dimensional, can be of three-dimensional. It is same thing. I mean, there is not such difference. You should feel difficulties. The moment you are working on one-dimensional information, that means in the spectral domain, then it is called one-dimensional convolution. Whenever you are talking about the images of one band, that is called two-dimensional, then three-dimensional. So these are all the different representations. There is nothing great here. Okay. So the neural aspects of convolutional neural network. Normally, our neural network looks like this. Okay, you have an input layer, you have output layer, and you have hidden layers. And these hidden layers are nothing but the representative information of the input. Now, if we want to see CNN as a neural network, it looks like this. Let us say you are having an image of size 32 into 32. Okay, and it has three band of informations. Three band means RGB. In neural network, what do we do? We stretch all this 32 into 32 into 3072 number of pixels, and for three bands we get these things. Okay, so as a whole you will get this many number of pixels, and all these things are flattened here, and that will go to a single neuron. Okay, let us say my output layer contains 10 number of neurons. That means why 10 number of neurons? Because I have 10 number of output class levels. Okay, so the first number of neuron actually take the informations of all these input images and resides. We call it activations here. Okay, so the number of neurons in the activation layer actually talks about the number of filter you are taking in your convolution neural network. Okay, now let us try to understand that one in this kind of figure. You have an image of this size. Okay, 3 depth, 32 height, 32 width. Okay, and you have filter of 5 cross 5 cross 3. You convolve that. Okay, now all these things will come here. These informations will be residing here. That means you are now dealing with one number of neural node. So the number of neurons in the hidden layer, whatever we can think of in the neural network, here we are considering the activation map. Okay, so the number of neurons here we take, that gives you the number of filters you take. The more the number of filters, the more the number of neurons here. So this is what the analogy you can say. I mean, we are trying to visualize the convolution neural network operations in a neural network point of view. Okay, so that is why we call it a convolutional neural network. Okay, and this neural network is nothing but a convolution operation is happening. Along with that convolution operation, there are two other operations. They are called ReLU operations and pooling operations. And if you combine those three things, then it is called as first step of this one, convolutional ReLU pooling. This is called first step of operation. Whatever output you will get here, that becomes the input to the second step of information. Like that, you keep on going for 3, 4, 5, 6, 7, 8 number of stages of information, and at the end, you will get the learned features. And those learned features will become the input to your classifier, and the classification output becomes your decisions. Okay. So let us talk about something on the ReLU operation and pooling operation. So what are those things? Okay. Okay, what is that ReLU operations? ReLU operation is nothing but one kind of activation function. And when you may be thinking that what for we are going for the ReLU operation? It's an activation function. We are going for the ReLU operation because of the certain problems we face in normal activation function, whatever we take in neural network. In neural network, we take what kind of operation function? This. Most of the time, we go for sigmoid or tan hyperbolic. And what are the purpose here? To bring your information range between 0 to 1 or -1 to 1. Okay, but what is the problem if you take this kind of nonlinear function? The problem is here. These functions are computationally expensive because you understand, no? The exponential operations are here. Okay, So sigmoid function is computationally expensive. They are not useful for the regression task as well. Okay. The problem of vanishing gradient comes into the picture. If you perform the partial derivative of this kind of activation function, then the problem of vanishing gradient comes into the picture. Its gradient becomes 0. The moment your gradient becomes 0, your weight parameter becomes 0. And your weight parameter becomes 0 means that particular information doesn't update itself. But your purpose of the neural network is what? You have to update your informations according to your requirement. If that updation doesn't happen, then there is no purpose of neural network. And that problem we face when we are having vanishing gradient problem. So the vanishing gradient problem is the result in a decrease in the prediction accuracy, and the model takes long time to train a model. So these are the problem of the activation functions like sigmoid and tan hyperbolic. That is why we go for ReLU operation. This is one kind of operations which we take, and this is the mathematical representation of the ReLU operation. So beyond 0, that means any value, input value is greater than 0, then we don't change that. If any pixel value less than 0, we make them 0. So this is what the ReLU operation, and it doesn't get affected by the vanishing gradient issues. But it has its own problem. What are the problems here? See, these are the ReLU operations if we perform on the images. So if this is the input image, this is the ReLU activation function output. That means all the values which are less than 0 become 0, and which are values greater than 0 are maintained here. There is no change. Okay. So the advantage of ReLUs are they are very simple and compute and easier to optimize during the learning process. And it gives you a faster convergence, okay, then compared to your sigmoid and tan hyperbolic. And there is no issue of vanishing gradient problem. These are the advantages. But at the same time, there are certain disadvantages also. Okay. So what are the disadvantages? The forcing of being 0 for all negative value called dying layer. That means whatever informations we are having here in the negative values, they become 0 here. That means in practical scenario, let us say you are unable to understand a particular aspect at some point of time. Okay. But there is every chances that in the next step of operation, you may understand that. But the moment you are performing ReLU operations there, that means your informations, whatever is negative in nature, that becomes 0. That means you lost that complete information. So there is no question of coming back from the dying positions. That is what the problem of ReLU. Because irrespective of your value here, all becomes 0. And that is the big problem of ReLU operation. So we need to make a compromise between these things. So the practical usage is that hidden layers of artificial neural networks are ReLU operation, but output layers are softmax classifier or tan hyperbolic or linear. That means not all activation functions we take as tan hyperbolic or exponential. We may combine this ReLU and softmax operations so that we get the, our purpose will be fulfilled. Okay. Then after that, we'll have another operation that is called pooling operations. There are two kinds of pooling operations. One is called max pooling, another one is called average pooling. Max pooling and average pooling happens like this. Okay. So for a certain patches, let us say my input image is like this. Max pooling means whichever is the maximum within this patch, that I'll only collect. So here 7 is the maximum, so I'll get 7. Here 9 is maximum, only 9. Here 8, like that. So this is called maximum pooling. There is another kind of pooling operation that is called average pooling. In average pooling, what do? We take the same patch, but we perform the average operation among the pixels value, and the average of all the things we take it here. These are the different kind of operations we call as a pooling operation, and the purpose of here is to reduce the sampling rate of the input signal. Okay. So together, the convolution operation, ReLU operation, and pooling operation talks about the one stage of convolutional neural network. like that, you can go for n number of stages of convolutional neural network. And once you are done, so what you can do? Once you are done with that, then you end up with this state where you get the extracted output. That extracted output, you flatten them and put them in a simple classification network, and that will give you the output. Okay, this is the holistic view of your convolutional neural network. And if you want to see the numerical part, I mean the size part, what is your input size of the image, what is the filter size of the image, what is the number of stride you have taken, what is the number of zero you have appended, and finally how many number of features you are getting. These are the things you can understand from these examples. Okay, this is just for the illustration purposes. Okay, so here we can say that layer 1 convolutional network, layer 2 convolutional network, like that you can go for n number of layers of convolutional network. Okay, and once you are done, you are ending up with the 250 number of features, and that 250 number of features will go to the some neural network, simple neural network, or SBM, or any kind of classifier here you can give, and which will give you the output. So the difference you can understand here. When our input signal was 32 into 32 into 3, how many number of nodes we were taking in neural network? We are taking, I think, approximately 3071 number of neurons. Just now we discussed, right? If that is the input size, how many number of neurons we had to take at the input layer? One minute, just where is somewhere. Okay. Yeah. So if you are having an input image 32 into 32 into 3, this many number of neurons you have to take as the number of, I mean, your neural network, conventional neural network if you are taking. But now how many number of neurons we have to take? 250 number of neurons you have to take as the input layer. So this is the advantage of extraction of the informations through convolutional neural network. Okay, so this is the first step of the convolutional neural network. This is the second step. First step is called information extraction. Second step is called model development using that extracted informations. Okay. So these are the different kind of hyperparameters that I already told you. Know the depth, stride, and zero padding. You need to adjust among yourself according to your requirement and according to your computational efficiency that you decide. Because there are certain equations are there which if you maintain, then you can get your desired output. Okay, if your input size is this much, what should be the output size you require so that you can give them to a classifier which will give you the better model. So you decide that, and accordingly you decide your number of filters, number of stride, and number of zero padding, and you will get your desired output. Okay, so this is about your convolutional neural. Earlier one is the autoencoder. So the purpose of all the things, common purpose is that they both tries to extract the representative features so that representative features can give a better result while they are fed to a classifier. In normal process, we use handcrafted features, but here the features are automatically evolved. They are not created by any fixed parameters or any fixed operations. Okay. Second thing is that the autoencoder is some way of dimensional reductions purpose. I mean, let us say our number of dimensions are very high, so we try to reduce the number of dimensions through autoencoder. Okay. Whereas in convolutional neural network, you also reduce the number of dimensions, but the operations here is either 1, 2, 3. So it is more advanced and more it extract better information about that images and videos rather than autoencoder. So that is the advantage and differences between autoencoder and convolutional neural network. And I think I just reached my time, 4 o'clock. So this is what I just wanted to discuss with you. And if you are having any confusion, any doubts, and any kind of queries, just let me know. So here I end my presentation.
Yes, sir. Meher, sir, now we can open to questions. Since participants, those who are having queries, you can ask.
Yes, yes, please.
Really nice presentation, sir, from the scratch, and you have given various inputs about the part where we can work, and really it was a nice thing. The delivery is a perfect one, as we
Yeah, because
expected.
I didn't go to the details of that mathematical derivation or mathematical operations of that one. I just wanted to give a kind of holistic view how and what for we are going for this autoencoder and convolution inverter. What are the motivations of the thing, and what these models can provide you, and what are the advantages you can get out of all these things. Yeah, please.
Yes.
Anybody is having any kind of queries and this, you please uh, do
Yeah,
that.
participant, you have queries you can raise out. Really, this presentation will be motivational for research scholars who are going to
Yes,
pursue
yes, yes,
their research in this area,
yes, yes.
and also for research publication domain, whichever is in this particular area, there that will be more helpful.
Yeah, yeah.
Uh, So I think there is no queries
Okay,
from participant.
okay,
So
okay,
almost
okay. Thank you.
everybody has gathered the inputs and insight what
Yeah,
you are
yeah.
giving.
You can share my contact number and email ID if anybody wants to contact me. You are welcome to do that. I'll be happy to provide you any kind of information provided I know. So I'm
Yes.
also a learner here. I'm not the expert. I'm also a learner. So if any of your participant wants to have a discussion with me or any kind of queries in future, so you just take my contact number. Please share my contact number and email ID to all participants.
Definitely, definitely, sir. We will share with them since we are sharing the resource materials and
Yes, yes.
everything.
I'll provide this material to all of you in a organized way. I'll put them and send it to you.
Yes, sir. You please mail to us, and
Yes, yes.
we will share with all the participants. It will
Sure,
be helpful.
sure, sure.
So it was a really nice presentation, sir, Mayor, sir. So thanks
Thank you.
for
Thank you.
sparing your time almost for past 2 hours.
Yeah,
And
yeah.
thanks for connecting with us. And this session will be a starting phase for some participants to take up their research paradigm in this area.
Correct, correct.
So with this note, I felt my heartfelt thanks to you on behalf
Thank
of
you, thank you,
our institution,
thank you
department.
to all participants for
Yes.
passion sharing.
Definitely, definitely, sir. Thanks a lot for
Thank you,
your presence for today, sir. Thank you very much.
thank you.
Thank you, thank you. And participant feedback link has been posted, so you can finish the feedback form. And tomorrow morning we will be having session at 9:15, and we have two resource person in tomorrow's session in morning itself. So one is from industry sector and another one is from R&D sector. He is also a very strong expert in this domain, as like our Meher sir and Nayak and Urvasi ma'am. He will be also a very good person to deliver the things. So tomorrow morning we will be having two sessions, and afternoon we will be having a single session. So please connect by tomorrow 9:15 a.m. So please complete the feedback form. Yesterday we have received only quite people have submitted the feedback. So please submit the feedback form today. Thank you. Thank you very much.